Hi everyone, happy Thursday. Welcome to HashiTalks Securely Building. I am Shala. Some of you may know me as Gifted Lane across social media. What I like to do is break things live with Terraform and AWS so you guys don't have to. So if you have any questions or comments, we'd love for you to interact with us in the chat. So definitely send questions. One question I want to answer real quick. As far as live captioning, I'll put the link in the YouTube chat in just a moment. But if you go over to the LinkedIn live stream, typically LinkedIn will do the live captioning for you. So quick code of conduct in this virtual space because we want to keep it safe. So in general, be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, be professional. It costs nothing to be nice, y'all. Like, just be nice, okay? So you can review our code of conduct at hashicorp.com/community guidelines that you see posted on the screen. And with that, let's get started. Okay, so let's go ahead and introduce the first speaker, Manu.
Welcome to HashiTalks, everyone. Thank you for joining the session today. Before we get into the details of the session, I want all of you to think about the last time you wrote some infrastructure configuration in your favorite IAC tool and had to go through some security reviews before it could be promoted to production. You realize that your organization follows a certain policy framework, you have a certain policy as code language, or a framework or a rule that you use. Or maybe you work with security consultants who ensure that your configuration matches their expectations. If you're in any of those scenarios, I want you to think about situations where new policies being added or new services are being added, which you're interested to consume, let's say from the AWS standpoint. How do you keep up with those? How do you add those policies? How do you update those policies so that your organization's policy set or the set of policies that you need to work with is continuously improved and still compliant with the frameworks that you want, or helps ensure that your infrastructure configuration is compliant? I'm Manish Chandrasekhar. I'm a senior DevOps consultant with AWS. I'm here to talk to you about crafting security policies for your infrastructure using Amazon Q. Let's set some context, right? I work with customers who want to provision workloads in AWS. And many of them use Terraform as their IAC tool of choice. And so when I work with them, there are a few things, and they may already have some policy as code frameworks or that they need to adhere to from the standpoint of security and compliance. They may have or may want to pick a policy as code tool framework or a policy as code tool from that standpoint. So what are the components involved at that point, right? We have the Terraform AWS providers, which essentially acts as the plugin or the source of truth for any target platform that you want to work with to provision those resources in. Terraform as such doesn't know what AWS is, but with the AWS provider, it does have that extensive idea about what a schema of a resource looks like and how to provision them. Policy as code, again, it has sort of become de facto in line with the DevOps movement, along with the IAC side, making sure that policies are not in a security consultant's mind or head or in a documentation's line somewhere. They're written, they're testable, they can be consumed across your lifecycle, and it's consistent. And your organization may already have a compliance framework that they need to use across the life cycles, whether it's CIS, whether it's NIST, or the foundational best practices which AWS wants everyone to follow. For the eagle eyed, you would notice that I did not say Terraform AWS provider, but rather Terraform AWS providers. Yes, there are two. AWS provider, which you have known and loved over the years, the AWS CC or AWS Cloud Control Provider, which has been in existence from around 4 years, but went GA last year. Again, there are multiple YouTube sessions, HashiCorp sessions, AWS-driven conversations around what this provider gives you. Essentially, it allows AWS and the provider engineering team to give you the latest and greatest of AWS services and features right around the time of launch. So that is just about the providers. Now let's talk about the policy side. Anyone who's currently on this call, I'm sort of thinking that all of you are familiar with the idea of policy as code. Essentially, translating the policies or the compliance frameworks that you need to adhere to, your infrastructure needs to adhere to, in the form of code, which could be tested, which would allow you to have that automated enforcement across your lifecycle, even from your development machine, even up to a CI/CD pipeline, which deploys it. Version controller, which means you can have it in a source control repository. Everyone can refer it, contribute to it. You're bringing the compliance early in the lifecycle, as I said, even from a developer machine standpoint. You can actually bring that up there as pre-commit hooks or anything of that nature, which helps you to ensure that the developers or module authors or anyone who's creating these Terraform or infrastructure configuration in general are able to create them in a secure fashion. Again, as it's written in code, it's available, it can be used across lifecycle, it can be consistent, it gives you that consistent experience across the lifecycle and at scale. Now, there are a lot of security, there are a lot of policy as code tools and libraries out there. I'm going to focus on two which I'm familiar with. And one of the biggest challenges with some of the tools or libraries is that you need to, again, they are good to start with. After a certain while, you would need to have that much experience in those specific policy languages to write those policies that you or your organization needs. And that's the same across all policy code tools. You have your own choice, you have your own favorites, or your organization has your favorite, which ends up being your favorite. To help support that, again, some of these policy code tools already have some pre-built libraries. Like Sentinel has some for AWS provider policies across CIS and I want to say foundational best practice at this point. Checkov already has some pre-built and added in by the community. So they all provide good enough starting points for anyone who's starting with AWS, deploying workloads in AWS. But what's missing here? Now, I said there are two AWS providers. When I looked at the policy listings and policy sets that are covering resources, helping you to deploy or provision workloads in AWS, it was missing AWS CC provider in its entirety. So I started on a goal. I want to add support for AWS CC provider from the policy frameworks like Sentinel, policy languages like Sentinel or Checkov, both of which I was familiar with. I haven't written a lot of policies, but I've written a few. So if I'm looking at, let's say, irrespective of what policy engine I'm taking, what are the steps which I should focus on before creating a policy or before creating a specific set of policies based on a framework? I want to understand and review that policy framework, whether it's CIS, foundational best practices, NIST, or anything of that nature. I want to identify the resources in the provider which they apply to or map to. In this case, I'm taking the case of AWS CC provider. You want to create those policies for each of those policy engines. Sentinel has its own DSL, its own language. Checkov can be written in Python or YAML. And you're not done there. Whenever a new policy is added, or whenever a new resource comes under support or comes under a policy's purview, you may have additional policies to be written. Or maybe there's a feature which updates the way a policy is inferred. So you have to repeat these steps over and over again on the basis of those changes coming across. Now, I'm not going to bore you with the details of or show you the details of policies that I've written. As I said, I started off with few after the tutorials. There were many. Now, the natural question at this point in time, in this juncture, is how can I automate this? Or can generative AI help? And I want to say much of this inspiration comes from the conversation I had with a few of the AWS folks and HashiCorp engineers I was working with at that point. And if you remember, we had a conversation around something similar using Amazon Bedrock and AWS CC provider documentation during the last HashiTalks. Some of the slides may look very similar because it's intentional. I want to make sure that this is sort of you can understand or follow along if you've seen that and it makes sense that, hey, this is the next step or the next thing in that series. So I started looking at the generative AI stack available to me. As I said, one of the previous HashiTalk sessions that we had was focused on using Amazon Bedrock with the orchestration layers to create those documentation with those examples and things like that. Now, in this case, our focus is on Amazon Q Developer, specifically the Q Developer CLI. The Amazon Q CLI refers to the command line interface of Amazon Q Developer, which is a generative AI powered system, which is designed to help developers, have that additional productivity within the AWS ecosystem. Now, let's focus on Q CLI at this point. I said this is inspired by a conversation or a talk that we had in 2025 about AWS CC documentation. So I'm going to bring in the hypothesis, which is very similar from how I had before. I had LLMs in there. In this case, I'm saying, hey, I'm going to give those details to Amazon Q and see how it reacts. Now, for me to create a new set of policies, again, this is on the basis of some of the experience, some of the learnings I had with respect to how Q reacts or any of those models at this point react. Peer conversations are asked around helping you create something. In this case, I wanted to create new policy examples or new policies specifically matching those specific policy frameworks. I need access to AWS provider schema because I wanted to be sure of what resources are existing. It needs to have access to AWS documentation for those specific policy frameworks. It ties those policy frameworks back to the resources it maps to. And interestingly enough, those policy frameworks also call out the CloudFormation schema resource, or it maps to the CloudFormation resources, which AWS CC also maps to. On top of it, I'm focusing here just on Sentinel, but again, it's similar in case of Checkov. I want to use the HashiCorp docs as a frame of reference for Sentinel policy language. There are certain nuances to the policy language itself and how you structure your tests, how you structure your mocks, and how Sentinel expects them to be in a certain format. If you've worked with Sentinel, you're already familiar with it. And in the course of time, I realized it helps to have some policy examples as whether it's from AWS provider or AWS CC that I wrote. For QCLI, use the additional information that I'm providing and use that to create the policies that I want. So the expectation is Q will use these examples and details to generate the required policies. And if you look at the first three things that I'm supplying, they are either documentation or existing provider schema and things like that. World has moved or changed a lot from the time I started working on this. MCP is a thing, and it definitely helps QCLI in this context, giving more details on what's possible with respect to getting more relevant information, more up-to-date information with respect to the documentation and the registry itself. So I can use the Terraform and AWS documentation MCP servers, augment what QCLI knows to help me create these Sentinel policies. Enough of the slides. Let's get into the demo. Now, in the demo, I want to showcase 3 things. We want to create a Sentinel policy from scratch. You will see the different motions Amazon QCLI goes through to identify the structure, go through creating the policies, and creating the documentation and things like that. And we'll see how we can scale it across different services from a security policy standpoint. And I did say this is for both Sentinel and Checkov. And I follow the same structure, similar mechanisms, and similar path with Checkov as a policy language. And I've created some policies also. And I want to showcase what the effect of those is on existing AWS CC resources that you may be using. So let's get into the demo. I'm going to pause in between to showcase, talk through what you're seeing in here. I'm going to start the queue interface with a queue chat command. And you can see there are 3 MCP servers getting initialized. The AWS Labs core server, which is required, the documentation server, which is going to help me solve through the AWS documentation, and the Terraform MCP server itself. Now, the first request in here is very simple. Hey Q, can you create Sentinel policies for the S3 control called S3 3.8 or S3.8 for the CIS policy framework? So I've defined the policy framework. I'm saying which policy or which security control, and I'm saying which provider I want the Sentinel policy to be created with. If you start to think, there are a few steps in here. If you notice. So it's going to tell you, hey, I'm going to try to create these policies for you. I don't know what CIS framework is at this point. I may have to examine the existing documentation available. And I'll talk you through the rules a little later. It has some existing tools available, like, for example, in this case, using the search documentation to identify what that S3.8 security hub control means. It's going to identify what that is, read through the documentation from the AWS side, in this case, CIS. Foundation policy or the CIS policy framework. And it'll identify that it is what it says as S3 general purpose bucket should block public access. So you identify where the control is. Now, if I scroll up, oh yeah, it's already trying to get in the AWS CC documentation at this point. Okay, so this is the second step. It's trying to identify if such a resource exists. That's it. Every one of these security hub controls have a CloudFormation schema resource, a CloudFormation resource associated to it. With AWS CC being mapped to the CloudFormation schema and the CloudFormation schema registry, it helps it much more that it's able to translate that resource into AWS CC provider. The thing that QCLI is going to do is identify if such a resource exists and if such a property exists for it to do their actions. Once it identifies the resource, it goes through the motion of setting up Sentinel policies. I've given it a simple CloudTrade policy or a couple of CloudTrade policies as an example, because Sentinel itself has its own structure. So I want it to be easy for on QCLI to be able to use that structure for Sentinel test to work. Then I create the S3 policies. And it's going to start creating the policy. So there are a few things involved in a Sentinel policy if you're newer to Sentinel. You have the policy code, per se. You have the test. You have the mocks for the test, which helps you test that particular policy against it. And in the meantime, it's trying to create those policies. You might see some failures out there, which is fine, because as we give QCLI access to Sentinel, we are essentially asking QCLI at this point to say, hey, make use of that particular tool that I've given access to, along with MCP servers. Test it, verify. If you see some issues, fix it along the way. And try to make sure the test passes. That validation is really important. Whether it's creating Terraform modules, whether it's creating Sentinel policies, whether it's creating any sort of code that we have, having a baseline of test, having some sort of mechanism to validate that what you've created is working, definitely improves your confidence in what that particular, generative AI system is creating for you. So QCLI, with my permission, was given access to run Sentinel as a tool in my local system. It goes through the policy structure, runs Sentinel test, and ensures they're passed. Once it's passed, you can see it's specifying what sort of running through verbose mode. There's a reason it's running verbose mode too. It's trying to get the details of what's running and the trace from the logs so that it can use it in the documentation. Now, I have these listed as a nice to have, but QCLI understands that once the policies are created, I want to document that because if you've ever published a policy library into Terraform registry, it's good to have some documentation out there. So this documentation helps you to communicate to the user that this is what you're trying to do with this particular policy. Now you've created the policy for it. And it's going through a structure similar to what we have in the document. So I'm opening Hero. That's my daily driver at this point from a coding standpoint or IDE standpoint. We're looking at the documentation that QCLI created for us based on the policy that it created. If you look at the policy, it already had a CloudTrail folder or a directory, and it created the S3 directory, the policies and mocks and the test out there. An additional README specifically for that particular S3 policy out there too. It created a Sentinel.html file which should have the additional policies if you added more. I did not add the one for CloudTrail, but ideally you should have that too. Now, how do we scale this? We only created a policy for a single resource against a single policy framework. That's not going to get us much. Now, let's see if we can scale this across different policies. Again, I'm doing this for all the SNS topic controls. Rather than creating it, I'm asking QCLI at this point to create an implementation map or implementation plan. Let's add a note not to include estimates, that's all. Now, what it's going to do in the background is it's going to follow the same process as it did before, using the trusted tools that it has access to. It reviews what SNS topic controls exist in Security Hub. It identifies there's SNS 1, 2, 3, 4. Which one maps to FSVP or CIS, which is the relevant resource on the AWS CC side, and found out that SNS4 is the only one which is part of FSVP standard. And now it's, once it identifies, it actually creates an implementation plan for us. In the sense that it'll tell you, hey, this is the particular resource that you have, this is the particular control that a particular resource maps to, and you should create a policy for it. What's the best thing about it? You can do that for all the resources and all the security controls that you're interested in and create implementation plans. And it can feed that back into QCLI and have it create those policies for you. With implementation plans, it's sort of a good mechanism to help you build that list of items that you are trying to create. And you can have QCLI mark the ones that are already completed and continue with or resume where it stopped off from the last time. What you've seen till now is a quick demo of how you can create Sentinel policies for a specific resource for a specific control and scale that up using an implementation plan for all the possible security controls for a resource or even further. So that's it for the creation of the policies, right? Now let's take a look at the actual rules that I had in place for QCLI to follow. As you'd expect, again, QCLI has been asked to create certain policies. And this is basically for Sentinel at this point. As I said, I've given it a role, saying you're an agent that is specialized in writing Sentinel policies. You're aware of the AWS documentation. There are certain things which I added to make sure it understands and it's easier for it to figure out, though it will figure out eventually. But as I work through the code, I thought it'd be easier to say, hey, for a CloudFormation resource that is mapped to AWS CC resource, it's an easy map as in replace the double columns with an underscore, things of that nature. On top of it, I was giving QCLI structure to follow from the standpoint of how a specific policy need to be written, the naming conventions around it, how tests and mocks need to be written as well. So it's able to follow that convention and create policies. And along with the example that we gave for CloudTrail, it was able to create the ones for S3 that we asked for. Now there is a certain flow in here. One of them is around, hey, what is the general structure and configuration that you want to have? There are some requirements that I want you to strongly create, like what I'm calling as should requirements. There are a few which is may, or some which is like nice to have, right? I asked for documentation. It actually created this documentation. So that was one of those ones that I asked for and created. And again, this is that what I'm showing you right now is the actual implementation map that is created for that SS topic. So what you're going to see is a simple example of an EBS volume, one which has encryption enabled, another which doesn't. We're going to look at checkout policies, which by default, which doesn't sort of fire on it because it is for AWS CC resource and the policy doesn't understand it. It is written for AWS at this point. Now, introducing the additional checks that I wrote, let's see how it behaves. You can see that the fail on fails, the pass on pass. The one that is expected to pass is pass because it is looking at that encrypted property on the ABS wallet, which is supposed to be set to true. So that's it for the demo. We looked at three things: creating Sentinel policies from scratch, creating an implementation plan, even though for one resource you could extend it or scale it for every resource possible. And the other one is just a quick validation of AWS CC resources using Checkov, using the custom checks. To summarize, it allows you to download and try Amazon QCLI and consider providing it access to tools with whatever tools you're working with, whether it's creating Terraform, whether it's creating Sentinel. Explicitly give it access to that, saying, hey, you have access to this particular tool to validate its own work. It actually does wonders because it helps to self-correct on the basis of the feedback, or if you have some specific steps that you use to validate, whether it's the same set of steps that you use to create that particular artifact, whether it's Terraform configuration, Sentinel policies, checkout policy, anything of that nature. Again, while I was doing all of this, I was still reviewing the output, some of them more on the basis of the tests that I have. Checkov is probably a little bit easier to validate with the tests that you can write in Python itself. There's definitely other use cases that where Amazon QCLI and a similar approach would work. They can create new resources in AWS provider when a new service gets released. Creating secure Terraform modules to start with, right? Getting that feedback around using security helpers like Ash, which has its own MCP server. Going through and reviewing your code as you write it. If you have failed security checks, use Amazon Q to sort of give you an idea of how to fix those. And in general troubleshooting. I want to leave you with a couple of repositories. These, have the custom checks that I'm talking about from a AWS CC standpoint, whether it's Checkov or it's Sentinel policies. Do take a look at it, give it a run. I'll keep it updated as much as I can based on the changes in policies, changes in the new resources that are coming across the AWS CC side. I want to leave this on more thing. If you're coming to HashiConf, there are a few other sessions. Again, one speaking session for me, which sort of continues the series from documentation to policy creation to other realms that I talked about. Value session would be the grounding AI and reality session would be more about the how of how you can bring determinism into the flow. Mine would be more about what additional use cases that I've had success with. And if you want to dive deeper into the MCP servers available, Gautam Bhagal session around from code to context is the best thing that you can look for. If you're there in HashiConf, please come by the AWS booth and say hi. Hope you found the session useful. I'll be in the chat, answer any questions that I can. Thank you for joining.
Thank you, Manu. That was great. So first off, y'all, I had never heard of AWS CC providers. So That's why I love coming to these kind of programs, because I always learn something new. So now I have something new to go dig into. So thanks for that. Another thing that I also keep telling people more and more, I'm totally a vibe coder. And I keep telling folks, the people who are able to use or work with these various AI tools efficiently and in a smart way, they're the ones who are going to be excelling like in their career like at a rapid rate, because they're going to be able to maybe 2x, 6x, 10x their productivity. And so I always love the topic of using, working with AI tools to, you know, make your work life better. It's always like that partner that's always ready to brainstorm with you. Quick announcement. Have y'all heard of Hashi Conference? HashiConf. Have y'all? Okay, because that's definitely happening in September. It's going to be September 24th through the 26th. I will actually be there for the first time. It'll be my first time going. Send me your tips. You can see on the banner down there if you want to buy tickets, find out more information. I will also be giving a hallway talk. I, kind of keep forgetting that I got selected to do, so I'll be there. So definitely ping me if you would like to meet up. All right, with that, I'm going to introduce our next speaker. We have Mahendran coming up next. They are going to start give us a talk about stop managing secrets blindly. I'm all for that. I'm interested to see what we get into.
Hello everyone, welcome to HashiTalks Securely Building. My name is Mahendran Selvakumar. I work Cloud and DevSecOps Engineer at Tata Consultancy Services and also HashiCorp Ambassador and AWS Community Builder. And I'm the organizer for West Midland HashiCorp User Group. In this today's session, I will walk you through about that HCP Vault Trader and how we can configure the HCP Vault Trader and how to enable that integration for alerting and what are the data sources we are using, what are the plans available for HCP Vault Trader. By end of this session, you will know how to configure the HCP Vault Trader with GitHub Cloud and also the Slack integration for alerting. What are the challenges we are facing in the traditional secret management? So in today's multi-cloud environments, we have that secret manager, but still the blind spots are there because we have that hardbound unused secrets, and also the secrets are hard coded in that code and config, and also that some of the overprivileged credentials with that no expiry dates, and we don't have the visibility also, correct? So the lack of the visibility, it will create that security risk as well. Due to overcome this one, so HashiCorp introduced the tool HCP Vault Trader. So Vault Trader is a HashiCorp managed secret observability tool, and using the HCP Vault Trader, we can able to do that secret scanning and discovery and disk classification and misconfigurations and detections, and also that remediation recommendations. So apart from that, we can able to integrate with that Vault and CI/CD and repository, and also that cloud providers, and also that conferences or Jira also. How HCP Vault Radar is works? So it works with that. So five phases like the discovery, analysis, and classification, and remediation and reporting. So in the discovery phase, it will scan that data sources well, like that GitHub, GitLab, and AWS and Azure and Terraform. So once in the do the discovery, it will analyze that credentials. Is there any hard coded credentials available, or public secrets are available, any PA data available, or any overexposed identities available? It analyze. Once it analyzes, it will identify the types as well. So like that, whether it's the AWS secrets or GCP secrets or HCP or vaults tokens or DB credentials, all the things will be classified. And also it provides that recommendation and remediations as well. For example, if we are using that HCP vault dedicator or vault enterprises, it will automatically rotate the secrets and also that delete the secrets as well. Apart from that, we can have that dashboard as well. So using that HCP Vault Trader dashboard, we can able to do that audit trail as well. So who put that password and what are the passwords will be the risk classification, like the low, high, or medium. So all the things will be we can direct in that reporting spot. And in that Vault Trader have the two plans. One is that free trial and another one is that standard. So you can also, the free trial is that 30 days period, and in that 30 days week you can configure that two data sources and 50 resources and or else 50 data sources. And then using in that free trial you can't able to configure that you can't able to it automatically not detect that detect or monitor the newly created resources. It's detect only that it monitor only that existing resources. And using the trial period we can integrate only the some of the integration tools like the monitoring tool, alerting tools like that Jira and Slack. But if we are using the standard, we can have that up to 2000 data resources and 20,000 resources, and it automatically monitor newly created resources. Like for example, if you are creating any files in that GitHub repo and any add any code in that GitHub repo, it automatically detect. And if any passwords or any credentials will be available in that code, it automatically detects and it will create that alerts as well. And we can integrate with that service now on Splunk and or PagerDuty and Microsoft Teams. All things we can integrate with that standard plan. And one more thing is that if you are initiate that manual scan, so you can able to do only one scan in that every 5 hour in that free trial. But in that standard plans, you can able to do one manual scan in every 5 minutes. And also that you can able to do that any custom expression in that free trial. But you can able to do that custom expression in that standard plan. So, and you can able to export that reports as well, correct? So in the free trial you can export only that the 100 events, but in that standard you can able to export that 10,000 events. And also you can able to configure that 10,000 namespaces as well. And in that free trial you can able to configure that 30 namespaces, so 30 namespaces as well. What are the data sources available in that HCP Vault? As of now, we can use that code server and content library. In that code servers, we can use that GitHub Cloud and GitHub Enterprise Server and GitLab Cloud and GitLab Self Managed and Bitbucket Cloud and Bitbucket Server and Azure DevOps Cloud and Azure DevOps Server. In that content library perspective, so we can have that Confluence Cloud and Confluence Server, but and the Jira and Jira servers will be that public beta versions as of now. And how we can integrate that tool. So what are the tools supported for the integration? So as I said earlier, we can integrate Jira and Slack with that both the free and standard plans. But in that Microsoft Teams, Badger, Tutti, and ServiceNow and Splunk will be configured only with the standard plans. So next we will see the demo. So how we can configure that HCP Vault Trader with that GitHub Cloud, and also that how we can enable that alerting. So these are the HCP portals. So you all know that's correct. So here I can have that HCP Vault Trader. So I already enabled that standard plan for this demo. So here we can have that data sources. In the data sources you can able to configure that, but what data sources you need. I will choose that HCP Vault Trader scan, and also you can choose that HCP Vault Trader agent scan as well. So as of now I'm choosing the HCP Vault Trader, and I'm choosing that next. Here I'm choosing that GitHub Cloud. So because I'm going to configure that GitHub Cloud, in that GitHub Cloud, so my organization is that SKMG 1077, and I need to have that personal access token. So here I am going to configure that personal access token. So I'm going to create that personal access token. So I need to give that multi authentications. So I'll give the name as that Vault Radar. So what are the permissions it's required to access that GitHub repo? So it reads the Git repo access and also the admin access, admin repo hook, and admin arc, and read user access. So these are the access needed to access that GitHub. Once I got that personal access token, so I need to give that personal access token and give that next. If we have the enough permissions, it's move to that next level. If not, it asks the record permission. So here I have that a number of repositories. So I mean the 31 repositories in my organization. Now I'm going to configure with one of the repositories. So that repository is to scan the configurations. So here I have that repository. So I have code in that repository vault data demo slack. Using that in that repository, I will configure that data sources. So instead of giving that all the repositories, I have chosen only one repository for the data sources. Once data sources configured, so we can enable that alerting as well. It's scanning that particular organization and what data sources we have given. So see, it's identify that risk, so the data sources will be configured in my repositories. It has that one high and one medium risk. So here, see, it shows the JWT secret, correct? So in my repository, it has the JWT secrets, and also that it has a high privilege, so the passwords will be the DB password will be given in the repository. This is that data sources I have configured. Here you can able to see the data sources. So the data sources will be that active monitoring, the vault trade or demo slack. So what we are going to configure now? So now we are going to configure with that Slack integration. So first we need to configure that connection. So I will configure that vault radar. So I'm just giving that connection name, and then I need to configure that Slack app. So Slack app. So in that, based on that bot use Slack bot user auth token. So we need to create an app. So I'm going to give that from manifest and and the workspace as the DevOps need. So this is my one of the workspace. Here we need to configure the JSON file for to configure that app. So here I have the code. So this is the code. I got it from the HashiCorp. So you can have the code in that HashiCorp website as well. So here I have given that what is that application. So why the application was using. See, here you can able to see that description as well. So if any code security could be improved with the same technique used to improve the code quality. So and here we can have the permission as well, correct? So the bot should have that chart right and incoming web access. So once I can't give that one, so it will create the application. So what we need to do, so once we created the app, we need to install that app in that workspace. So here, these are the channels I have. I need to configure that alerting for that one. So these are the Slack channel I have. So I will give that allow permissions. Once I give the allow permission, so I can have that bot. So these are the bot tokens. So these tokens we need to configure that HCP Vault traders. Once you given in the test and save, see he does the successfully created the test. So once it's created, we need to configure the subscription. So that's if here once we created the connections, I need to choose that one. I need to give that subscription name or trader subscription, and also that event filters, and also that what is the channel name you are going to configure. So I have that I have the Slack channel. So just the Slack channel name is that Vault Radar GitHub Wallet. I'm going to give that channel name, and also that here you can able to see that. So because the HCP Vault Trader integration is added to the channel, correct? Because we configured that, and also here you need to add this app to the channel. So once you add the channel, it automatically triggered that alert. So here I have added that app to that channel. So now what I am going to show, so once I have given that enough details, now I'm going to test and save. Once tested, it successfully created the new subscription. So now the connections will be created and subscription will be created. So in case if finds any alerts, it automatically initiate that alert. So now we configure that alerts and other things correct. Now we have I'm going to do some modifications in my repository. So Vault Trader demo slug. This is my repository. So in this repository, I have configured with that HCP Vault Trader. So what I'm going to do, so I'm going to change that file. For example, so here I have that DB host and DB port and DB user and DB pass, correct? And one more thing is that, so we already integrated that Slack channel. So if you go to that Slack channel, here you can able to see that test message. This is a test message sent by the HashiCorp Vault Trader to validate the channel information. So it now we can able to see that. So the alerting will be triggered. So I'm going to add that passwords here. So the sum of the file, like the password, pass 1 2 3 4 5. So I have added that path and I will commit that file. So once I added the path and commit that one, and if you see in that T1, here it when the run that next things it will be detect. So here you can able to get that message as well. So whenever that secrets or password, see here you can able to see that one because the password assignments in GitHub Cloud. So if you see the findings, it automatically go to that particular file and the on line of the code, so where we added in that password. So this is the things we will be see. And one more thing is that, so we can add that AWS access key and secret key as well. So if we, for example, here I have that code here. I'm going to add that in this code. So I'm going to add that AWS access key in that one. For example, so I'm going to create that branch. So new branch will be created. Vault if radar. So I'm just creating the new branch. In that new branch, I'm going to do the changes in that configuration. So I will edit that file. So for that AWS access key ID and AWS secret key, so I have created that AWS user already. And I am going to create that access key. So in that access key, I will get that access key and next detect, and I will create the access key. So now I have that access key. So I will give that access key in that configuration file. I'll give that access key and secret access key. So now I have configured with that AWS access key ID and AWS secret key in that code. Just I commit that one. Once I committed, so it will say that by default it GitHub show that one. I will give that fix in later. So in that case, it will allow to configure that. See now the particular AWS access key ID and AWS secret access key will be committed in that repository. So now the files will have that. If you see in that Slack channel, by default it will create the alerts in some time. And one more thing is that, so you can able to see that events as well. So if you see in that event, so here you can able to see that one. So if you see here that you can see that correct the password also, it will be triggered. So it will create the alert for the AWS access key and secret access key as well. See here, you can able to see that one correct. So yeah, now we added that AWS access key ID and secret access key in that repository, but the particular HCP Vault trigger that alert to the Slack channel. So if you see here, see it automatically notify that AWS access key ID was added, and also that it will notify that AWS secret access key as well added in that GitHub repository. So that's what HCP Vault Radar is doing. And one more thing is that, so we can integrate that HCP Vault Radar with that pull request. So we have that CP Vault Radar checks up. Using the CP Vault Radar checks up, you can able to integrate that particular application with that repository. Once you integrated with that repository, so if you do that pull request, it automatically scan that particular repository. So for example, so I have added that GitHub Vault Radar, and now I'm going to raise that pull request. So in that pull request, so give that create pull request, it will check that merge compatibility, because for example, so we added that HashiCorp Vault Radar secret scan application into that repository. By default it will do that scanning. So in that once the scan passed, we can able to merge that one. If we have that enabled, that branch protection suits, we can't able to do anything in before passing that scan. So now that HCP Vault Radar secret scan app scanning that repository, once the secret scan will be scanned, so we can able to see here, you can able to see that failed secret zips branch. So if you see the details here, you can able to see that secret. See here it will mention. So it has that critical severity, and also that it has that active, and here you can able to see that. So what is the failed status? So because it has that for example, the AWS access key ID and secret access key stored in that particular main.tf file. So that's what we configured with that pull request. So it should be passed. See here, you can able to, so if we enable that branch protection and all of the configuration, so we can able to merge the code without passing that particular repository. So that's all CP Vault Radar is doing. So we can able to trigger the alert, and also we can able to trigger that notification as well using that HCP Vault Radar scan. So thank you all. So if you are using if you are using Vault, there is a chance to configure with the HCP Vault Radar, and if you are not using the Vault, this is the right time to configure the HCP Vault Radar and to scan and to protect your environment without blind spot. So thank you all. This is my LinkedIn blog and HUG code. So if you want to connect with me, and if you want to learn more about that HashiCorp Vault or any HashiCorp tools like the Terraform and HCP Vault Radar, please ping me in LinkedIn. I'm happy to support and I'm happy to help. And I have written multiple blogs in that my website DevOpsNet. You can go through that website, and in that West Midland HashiCorp user group, we are organizing that in-person and online events, and we are distributing the voucher based on the raffle. So you can have, you can, if you are willing to join the community, you can join the community, and you can, if you want to speak about any HashiCorp tools, you can join, and you can provide the speak as well. Thank you all. Thank you for the opportunity once again. Thanks for joining the session.
Okay, so let that be y'all's reminder to go revisit and think through whatever your latest secrets hygiene is. That's y'all's reminder. Me personally, I love this, and this is something I literally want to go play around with. and see how I can implement it for my teams that I work with, because I'm forever trying to like scrub and make sure there's no secrets like hard coded in any code or anything like that. That's always like my greatest nightmare. So I think that was an amazing talk. It was well explained. Love it. Let's keep it rolling. I'm going to introduce our next speaker. And the next speaker is going to be Rinaldi. And they are going to talk about tripwire secrets on the HashiStack. So I'm curious to jump into this and see what this is about. Let's go, y'all.
Hello, everyone. I hope you're having a great time at HashiTalks so far. My name is Rinaldi, and today we'll be going over tripwire secrets on the HashiStack. In security incidents, the real damage that you have often starts long before anyone notices. When a token is copied, a role quietly expands or a key lingers in a log. Today, I'll show you a containment-first approach using the HashiStack to turn identity into an early warning system so we can stop attackers before they start moving. So, without further ado, let's get straight into it. So, to start off, I'm, as I mentioned, Rinaldi, and currently hold all 14 certifications from AWS, and I'm also an AWS community builder. I am also an instructor and an author. I've instructed many courses relevant to programming and generative AI and software engineering, and I currently am also writing the Azure AI Engineer Associate Study Guide. I am an international speaker at over 50 events and conferences. I am the organizer of the Melbourne Python Meetup, and in general, I enjoy all things AWS, open source, generative AI, and virtual reality. So, what agenda are we looking at today? First, we'll be looking at quiet privilege creep, which is essentially a bit of a look into how we can map escape routes and understand a bit more about the motivation for this particular talk. After that, we'll look into placing the bait in the sense of using canary secrets and also signed hints. Third, we'll then be looking into first touch containment in regards to rotating, freezing, and breaking where necessary in our deployments on the HashiStack. Fourth, we'll then look into tools in action which involve using Vault, Boundary, Consul, and Terraform. Fifth, we'll then look into rollout, which will outline a 4-week plan of how this will look like, having specific drills and metrics in place, and also having specific understanding specific gotchas within this kind of system. So, oftentimes, things start very quietly. No one notices anything. It's just a matter of how we decide to notice it, and when we actually do notice it, problems spread quickly. So tokens are often copied for just for a minute, but the role is then broadened for just a simple deploy. And as part of this, oftentimes there are issues that start to pop up. The key often lingers within a particular build log, and oftentimes alerts start to occur, but they only make sense after a blast occurs. This is all the startup, the setup for a particular incident to happen. And of course, for those who are used to responding into incidents or those who are normally looking at production incidents in a post-production incident review, we often come across this often too many times. So it's something that we always have to deal with, and it's something that we have to get accustomed with. And the question is, how do we prevent this from happening, and how do we strengthen what we do in these kinds of regards? The premise is we don't want to chase attackers. We want to trip them up, hence the name of the talk. We want to be able to be the first touch, essentially, provide the containment before necessary escalation. because we want to try to be able to contain particular threats before we actually escalate into something that we don't even want to deal with later on. And of course, identity becomes the early warning system of understanding how the identity in particular we can actually deal with, and essentially ensuring that we have the relevant identity management system in place. That's really the premise setting this up. So what is the cast that we're looking at? The cast is comprised of 4 different things. We have the vault, the boundary, Consul, and the runner. Vault itself serves as mini canaries. We have provided by sign hints and ensuring that we are also able to rotate keys fast as well. Boundary, in which we ensure just-in-time access, ensuring that we also have believable constrained targets that we are setting for ourselves and for the definition for Vault, Consul, and all the other relevant services that we will need. Consul, essentially, our intentions as breaks. It helps us set safe policies and ensures that we appropriately apply it where necessary. We then have the runner, which executes the containment, which involves tools such as Nomad or Webhook. These all help to be able to orchestrate our particular roles and our particular services in a very good fashion. So in mapping the escape routes, we can then look at it in terms of how we choose to be able to have the services run through. So from the cloud itself, we often have stale keys, overbroad roles, which oftentimes are the easiest ways that attackers often access these particular services. We have the CI, in which sometimes logs leak. The artifact registry credentials as well might often be a bit outdated. And that's why essentially we need to ensure that we have the proper deployment processes in place. And in terms of data, oftentimes there's shared admin and lateral DB hops. So what we really need to often do is, how can we draw the shortest path to the crown jewels? Which of our artifacts and which of our current setup really allows our attackers the shortest path towards being able to achieve the crown jewels? So that is essentially what we always need to be thinking. Put ourselves in attacker's shoes and see how that is able to lead them towards the crown jewels that we are trying to protect. In which case it's often our system, or it might be a production deployment. And there's often many ways that attackers can access this. And it all depends on us to be able to ensure that we have the appropriate security in place to ensure that they don't easily access this. And that's where canary design comes in. We have something that looks valuable, bit of a harmless backend essentially. Time to live have within like 2 to 5 minutes, auto revoking. And then implement also like sign hints essentially, in which case we put in a specific owner, we put a specific scope, we put a specific change ID, and we also in general put a specific read use trusted signal as part of this. So we want to be able to design for a particular canary design so that we can essentially have these particular best practices in place while also really testing out how our systems would perform with a particular canary design. And for a particular look at the code, we can look at this for instance. So for Vault Secrets itself, we pretty much would be firstly like enabling the particular database. We then would look at using Vault to write the database config to this particular canary DB that we have. We then pretty much can put in the plugin name, connection URL, the username, password, and of course this all pretty much is just placeholder values. Don't name your secrets or your passwords or your usernames that way. And of course putting a specific allowed role as well, what is necessary as well as part of that too. So as you can see, we're provisioning a bit of a honeypot DB in that sense, and we're trapping attackers that way. So we then look into then writing another particular database in that sense, in which we then look at creating particular statements with create role. We create the specific roles, specific passwords, specified a specific like default time to live and a max time to live. So this way we're starting to create the specific canary vault role for our specific DB. So this way we're able to start attracting attackers towards that instead of our actual production environment. So that is really what we can start to utilize the HashiStack for, starting with Vault. We start to essentially craft a bit of an architecture that we can lure attackers to and prevent them from attacking the actual source. Continuing on with signed hint, we can essentially look at firstly then using Vault to enable transit, setting it appropriately to true as well. We then can write the specific transit keys, the change ID, set the type to ED25519. We put the specific hint then, in the sense that we are specifying what the owner is, what the scope is, what the tripwire is, and accordingly providing a specific signal as well. So we're essentially writing to Vault as well based on the change ID, and we're essentially putting through, in terms of canary, the specific format, the database, the credentials, and appropriately, we then put specific paths as well, as you can see over there too. So then we, for instance, like the payment path, we put the specific credentials, the hint, the signal. So this pretty much like helps to set up the signed hint and the min canary architecture. We then look at wiring the specific bell in this sense. So we look at enabling Vault Audit to be able to look at how we ship read events. So we want to be able to ensure that when we do enable the Vault Audit, we're able to have the read events essentially being shipped appropriately. And we then look at having the first read being done to be able to have the containment run then being done. And we then want to look at rotating specific neighbors, which also involves freeze groups and appropriately flipping the safe policies as well as necessary too as part of this. So these are considerations that we need to make and what we need to craft towards being able to ensure that our architecture is robust. So here's another piece of code. So we also want to be able to implement fast rotation and revocation. So what we will then do is that we start to be able to rotate for the neighbors. So we then use Vault to write the database prod.db, and we also then look into being able to rotate the root appropriately too, for instance, in this case for neighbor rotations. We then want to clean up the specific sessions as well, so we can use Vault to also write and appropriately using the auth, we revoke the orphan as well. We have the assessor set, and appropriately we also revoke the lease as well based on specific app credentials from the database too. We can then look at guarding the boundary. Really, there's no standing creds that we should have. We should have like a strong identity that is set up. And this is where we start to introduce boundary bit by bit. So we want to have a short session time to live. We want to have record sessions essentially set in place. We need to have believable canary targets. So they need to have least privilege implemented as part of that. And we need to essentially set up an environment as robust as possible, but at the same time, it's as believable as possible to be as canary targets to be set up as that regard. And we need to be able to also catch the relevant harvesters without touching the production environment. And this is always the bit of a tricky part, because oftentimes when we set up these kinds of deployments, it's always a question about, okay, how believable do we want to make it so that people actually do believe with the particular thing that we are selling them, and that so we can essentially prevent them from later on trying to break into the system and providing them more access than necessary. And that's why, although we're making canary targets, we should still implement least privilege, ensure that the environment looks as believable as possible, and provide the relevant know-hows to be able to ensure that attackers still do try to go for it, but at the same time, they don't touch the production environment. This is all very important so that we ensure that we are on the right pathing with this. So when we look at boundary itself, we can see, for instance, from this particular deployment that we can define a particular boundary target for the Canary DB. So we first start off by specifying the scope. We have var.scope for specifying for that. We then make it as a TCP type. We put it as a Canary Postgres as the name. We put the default port as 5432. We then set up the session as max seconds as like 300. We then start to use a brokered credential source ID. We basically just initialize the particular ID that we have from the Canary DB from the Vault library. And we then look into utilizing the specific boundary credential library Vault, which we then set up, which includes the Vault address, token, and the pathing. So as you can see, we're really setting through the specific deployment configurations, and we're making it believable as possible to a production environment so that attackers do stay within the Canary environment and do not stray off into the production environment, which we should at all costs avoid them from doing so, because we are pretty much trying to steer them into the production to the Canary environment after all. So with this, boundary really helps with pretty much providing a particular target so that we can also utilize the Vault library to be able to assist it in doing so, to be able to make as robust of a deployment as possible while really being able to ensure that we are able to create a believable environment as much as possible that way. So we then can look at locking specific doors and keeping hallways open. In other words, with Consul. So with service defaults, we can fix protocols and mesh knobs essentially. So the intention we want to be able to do is to be able to allow for normal and deny risky flows essentially. So we can essentially have specific guardrails in place to be able to ensure that normal traffic goes in, but at the same time we deny risky flows that might try to go in, and that we can also flip to specific safe policies within Canary signals as well. So this is the great thing that Consul is able to help us do so that we can prevent from such threats from coming into our system in the first place, and flipping policies where necessary too, compared to, for instance, like if the system is under attack, when we're trying to redirect the pathing as well. So this is very useful for being able to ensure for that to be able to be put in place. And that really helps a lot in maintaining the system. So again, we can look at another code sample. So in particular, from our boundary target that we had, we can also then look at specifying the specific kinds as well, the specific names as well that we have as part of like the payments, the protocols as well that we have. And based on that, we very much like then specify the kind to be service intentions. We, for instance, like have a specific pathing that's named payments, and from that we then specify specific sources. And since we then specify the name to be API, ETL backfill, so we then start to redirect this way. So we essentially are putting through the specific hallways, but at the same time we are essentially putting through the believable aspect, but at the same time we're also getting ready as well to flip accordingly based on specific signals as well that's sent through. So we also want to ensure that we keep heroes credentialless in this sense with Terraform. So one practice particularly, for instance, is we have CI pull 5-minute STS tokens via Vault and pretty much have every act plan apply, which carries a signed change ID. This way, we can ensure that all these are actually valid and we actually don't use specific credentials, because using specific credentials always brings forward a potential attack surface. So being able to ensure that there is not such an attack surface to exploit really helps with being able to reduce the surface area of potential attack, and thus really helps to be able to help reduce the impact possibility for this kind of threat. And that way we also have no long-lived keys to steal, because that often is one of the biggest pain points and one of the biggest threat vectors that attackers try to leverage, which is basically the long-lived keys. So with reducing that, we in general help to be able to also prevent that from being a potential threat in the first place. And that all can be achieved with Terraform. So as we can see, for instance, from this particular code, we essentially can define Terraform to work with Vault AWS STS, for instance. So we have data with Vault AWS access credentials defined with Terraform, and we have like the backend being set up with AWS. We have the role pretty much set up as Terraform admin, time to live as 5 minutes, and accordingly, we then specify AWS as well as the provider, specific access key, secret key token. But in general, we're avoiding long-lived keys to be prevalent within the pipeline, essentially. And we can then look at connecting specific clues as well. So how do we look at having specific like sign changes ID as well? So we essentially have the specific transiting of the signs for like the actor, ticket, timestamp, these kind of things we need to be able to have logged appropriately and also leverage this signature as well. So the signature travels with out-of-band edits in particular and responders essentially towards specific threats or specific other potential key impacts can really respond and join the dots within minutes to be able to really react to these situations in a much faster way. So what would the rollout be, or in this sense, like the rollout montage? Well, firstly, in week 1, so this can be achieved in 4 weeks. So week 1, you need to draw up the paths first. You need to pick 10 tripwires. What do you think what the tripwires you target would be, and what are the main paths that would lead to the crown jewels essentially? In week 2, you then look at having the wiring the vault, essentially the boundary, the console. You would essentially look at wiring this up to be able to have them respond and react in the way that you expect them to, and of course also pretty much like have the runner in place to ensure that all functions properly. You then would look at week 3, in which you can schedule dry runs. You have the rotate and policy flip drills. You appropriately have that in place and ensure that they actually do function as you intend to. You need to ensure how you look at how the attackers respond to things, simulate probably black hat attacks as well for this regard. Like try to see how that particularly like would pan out if say like the canary was targeted. Is there any chance of reaching the production environment? You need to understand and put yourself in attacker's shoes to be able to ensure that these tools can keep you safe, and also what you have already created with the scripts they've created and also the impact boundaries that you have will also keep you safe too. So these are very important to have, and these drills are very important to continually simulate and just see in general how that particularly works for you. And finally, in work 4, we then ship. Accordingly, we see how the MTTD and the MTTC accordingly drop as well. So, of course, that's subject to a proper implementation. Like that's why, in general, this is always going to be a continuous improvement process. You need to continually look at how you're currently shipping this, and you're going to continually see how the metrics are performing, and accordingly make changes based on that as well. So this is pretty much like how you'll be looking at putting through this and appropriately really looking at how you will continue delivering based on that, because oftentimes it's hard to get this all right in one go, especially because sometimes you need to cover a large surface area and understand your production environment first and foremost, and also putting yourself in the attacker's shoes. So all this really needs you to be able to get used to it, be able to iteratively develop based on what you already have, and really understand more about your system. So oftentimes you don't get this in one go. It's something that you continually have to develop over and over again. So in terms of drills and scorekeeping, oftentimes having a monthly 15-minute micro drill is a great thing, because even if you already have yours setup established, you still need to continuously build on it. So having 15-minute micro drills really helps in continually looking at, okay, how is our system responding? Are our responders responding well based on the system? And is there anything else that we need to address? These are key questions that we need to always ask as part of these kinds of deployments. And these are how we ensure that our system is continually updated and really ready to tackle any particular attacks that might come its way. We can also track the MTTD and the MTTC and also the FP rate accordingly, and accordingly fine-tune our deployments based on that, and also tune the time to lives, the placements, the noise budgets. These are all things that we need to keep into consideration to ensure that we are providing the best as well as part of our system too, to be able to ensure that it actually is working as it should, it's not flowing into production environments, and that it should properly really get through what we need. So some gotchas and trade-offs. One big potential problem is often if you have like noisy canaries that cause issues without any particular issues actually occurring. So in this case, you would look at throttling and randomizing it. You would, if the TTL is too short, well, it causes friction. And oftentimes, if it's too long, it might be a risk too. So it needs to be fine-tuned based on how you decide to look at implementing it. And that's why it's a continuous improvement process. And oftentimes, the canary targets as well must not track prod data. So that's something that you need to be very careful of as well and set appropriate boundaries for. Although we need to mimic it as much as possible, it should not touch prod data. So who flips a safe policy? Well, we need to be able to have that documented and appropriately gated as well, so that specific stakeholders and users who are responsible for specific parts of the system, and also who is in charge of improving it, and also in charge of like who's flipping the safe policies, can be well documented and should be put in place essentially. So what do you leave with? Well, to start off with, you leave with a playbook. You leave with understanding the particular tripwires that you have as part of this, and also how you look at rotating and also breaking accordingly too as part of that playbook. You look at sample roles, policies, targets. We've seen some code examples for that, including as well looking at the Terraform pattern as well for ephemeral crits. So remember the fact that we want to essentially create as close of an environment as possible, but at the same time, we don't want to fully replicate that. We clearly don't want to target prod data. We don't want them to leave with prod data. So we need to ensure that attackers really can get as authentic of experience as possible with our canary deployments, but we don't let them touch the prod data in particular. And this is in general a way to prove that your timeline just got shorter for being able to implement this kind of deliverable. So because it's not at all, I feel, a very complex thing. We're just implementing more safeguards through this quote unquote honeypotting process with our canary deployments, so that we can essentially help to ensure that our systems are safer, and that we can ensure that there is more safeguards before attackers actually directly get access to our production environments. So that is all for me. Thank you again so much for listening to this talk. And feel free to connect with me on my socials as well. Happy to pretty much like take any questions after the conference too, based on these particular socials or my email as well. So yeah, that's it all for me. So I'll hand it back now.
Thank you. That was a great talk. I think it was a great follow-up to Mahindran's talk about HashiCorp Vault radar and setting that up. And I love the shift from, instead of waiting to be attacked, it's, coming from the mind frame of being attacked, because I mean, it happens. I see it all the time in my job. And so I really love the mind shift of, what if we could just trip up the attacker in the first place? And so they just never get to prod because they just trip over their own bad behaviors. I think that is amazing and brilliant. All right. We're going to keep it rolling. And so next we have up is John. And John is going to talk about securely automating legacy email workflows. Ooh, nice. Okay, let's get into it.
Hello everyone. So today we are going to talk about how to securely automating email response. So we do have an email response, Oracle email response. So as of now, we are integrating Siebel with the Microsoft Outlook through IMAP and SMTP profiles. So we are not sure it is securely automating. So we can automate like to email response. Whenever sends an email to email box, so we are sending back the response based on the email subject and body. We are not sure we are securely automating. So we do have an automation, alternate option like automatic legacy email workflows, like email response with HashiCorp. The challenge as of now, Siebel email response remains mission like critical. The core communication system must integrate with the modern infrastructure. Like you have to follow the protocols. Strictly, we have to follow protocols, and we have a lot of complaints, like not exposing credentials and the scalability for all hybrid environments. As of now, we do have a lot of hybrid environments, so we have to follow some security protocols. Since we have modern environments like AI, and we have so many technology, so many organizations in public sector, right, cannot simply replace these systems. Must involve securely. So even I read many corporates like they sued due to security breach, PA information and credentials. So we have to follow this kind of security and compliance requirements. So we are introducing HashiCorp, like it securely. So the advantage for this HashiCorp, like secret management, dynamic credentials, securing email protocols in IMAP and POP3. Even I hardcode many credentials in email response because there is no option for them, right? You have to make it work. So there is a zero trust access control for administrative interfaces like background processing. We do have a lot of workflow background processing to process all service requests through email response. So together, this HashiCorp tool establish a security, like a secure by design frameworks, bringing modern security and operational alliance for all Siebel email workflows and response, right? Next. So the general architecture for Siebel email response, the email response server and communicating with inbound server and inbound communication manager and inbound processor workflow policies. So it will route based on the subject and the email body and the sender. It will receive and process, and it will route it to workflow policies based on your request, and it will respond back to you automatically. The security challenge, as I told before, like it has hard-coded credentials in all profiles, SMTP and IMAP profiles. It does not have encrypted the configuration, all configuration of whatever we are doing in inbound email response. It is unencrypted and lack of granular controls, and we have to do a lot of manual processing. So manual provisioning we have to do through infrastructure. So securing email protocols with Vault. Legacy email response systems typically store IMAP, SMTP, and public credentials directly in the configuration and the database files. But HashiCorp Vault enables dynamic credential generation with automatic rotation. It will dynamically generate instead of static, as of now what we are using, and the time-based expiration. So there should be expiration. So we have to. It's a kind of certificate. So secure certificate. We do have a lot of applications. We are using secure certificate every year. We used to renew. So like that, we are going to use for Siebel email response dynamically credential generation, so it will expire and we have to renew it again. So it will reduce a lot of attack surface. And infrastructure as a code, we can use with the Terraform. Create Terraform templates for Scalable application servers, database servers, and the components, email processing components. So we have to configure connectivity, define network security groups, like we are using in our Scalable email response inbound servers. So we can define the network security groups and also integration points with all email systems as well as load balancing. We can apply the policies to Sentinel policies for compliance and security standards. And finally, we can automate the deployment, use CI and CD pipelines. By the teams can version control changes, we can use it and ensure consistency deployment. And zero trust access with boundary. The challenge as of now, we have Scalable administrative interface and background processing system often required access that difficult to control and audit. But if you go for HashiCorp, boundary provides the solution just in time access with fine-grained control based on identity, time constraint, and workflows approval. The benefit: administrators access only what they need, when they need it, with the comprehensive and audit trails, and based on the security governance and compliance. Real-world implementation case study. Financial service firm. Before manual Scalable email infrastructure provisioning, it may take like 5 weeks or maybe 4 to 6 weeks. Static SMTP credentials updated annually. VPN access to admin interfaces with limited auditing. No separation between development and the production environment. Okay, so after this, automatic provisioning, reduced hours with Terraform, as we talked about earlier. Dynamic SMTP credentials rotates every 24 hours via fault. And just-in-time access with approval workflows via boundary. Complete environment separation with consistent policy. So this results 87% reduction in security finding during annual audit while improving operational efficiency. So mostly public sector compliance alignment, FedRAMP, moderate, automated access reviews, credentials rotation, as we talk about the 24 hours, encrypted data. And NIST 800-53, least privilege access, separation of duties, continuous monitoring. So that's very important, continuous monitoring. WISMA, comprehensive logging, change management, incident response. And section 508, administrative interface, accessibility, alternate access methods, and documentation standards. So these are all the agencies to maintain legacy Scalable email response while meeting the stringent compliance requirements through automation and policy as a code approaches. So it's a roadmap, like how to implement this mode. Like we have 3-4 phases. First, assessments as usual, 4 weeks for everything. Document current Scalable email flows. Identify security gaps. So we do have a lot of security gaps and compliance requirements. Map integration points and dependencies. Then foundation. That will make 6 weeks. Maybe you can make faster, like we can deploy the tools, HashiCorp tools in non-production, like SAT or pre-production or even UAT or dev environment. They create initial Terraform templates, like regular email templates. We can initiate Terraform templates, configure Vault authentication method. That's very important. And then finally, the third step, integration. So the first, assessment, foundation, and then the main thing is integration. You can modify Siebel components to use Vault API instead of the regular Siebel components object manager. We can use Vault API, implement boundary access proxies, and create CI and D pipelines in deployment. And then finally, production, 4 weeks. This integration will take 8 weeks because we need to see the traffics inbound and outbound. Like this kind of integration, we have to see the request and response from Siebel and other system like. And then finally, production, 4 weeks, migrate production infrastructure to Terraform, enable secret rotation, monitoring, and then that's very important, and the conduct security violation, security validation, and user training. The phased approach minimize disruption while gradually improving security and operational capabilities. So key takeaways: modernize without replacing. HashiCorp tools enable secure automation of Siebel email response without complete rewrite. Shift from static. As of now, we are following static, so it's a dynamic, as I told, 24 hours rotation. Replace hard-coded credentials, manual processes with automated provisioning. Adapt zero trust principles. Implement least privilege access controls. Just-in-time provisioning for administrative function. So you can contact, there is an email provided here if you need any documentation or any information or inquiry. So how to replace hard-coded credentials, shift from static and dynamic, or even if you want to maintain legacy systems with monitoring. Sometimes email, we don't know where it goes or not, or whether we are getting activity, or do we have any audit or proof. So any kind of questions or documentation we can request from HashiCorp. So yeah, we have, even we do have a compliances, and then the main reason here, right, we do have a lot of security issues like exposed email. There is a user keys and emails are exposed, and those kind of issues, like it's a complaint, right? So security breach, we can use this HashiCorps, and yeah, pretty much we are covered. So SMTP and POP3 profiles, we can use this. Thank you.
Okay, so I think we can all appreciate the leap from slow manual pain to fast, secure automation. Big thanks for walking us through that. We got to walk through from maybe we'll update credentials this year to rotate it every 24 hours. That's awesome. Now, let's go ahead. We're going to keep it moving. Next up, we have Paras coming, and their topic is fueling innovation. Let's go.
Hi, this is Paras from Get this side. I hope you're having a great session, learning different areas, different platforms, different technologies in the HashiTalks securely building. And here I am covering another great aspects of AI ML, where how we can secure and create a resilient network foundations so that our AI and ML platforms can work seamlessly, securely, and reliably. So while we fuel the innovation with AI and ML, we want to make sure that the network foundations we have set up is pretty much strong, secure, and safe. With that in mind, here we have a couple of opportunities in AI and threats in AI that we would like to start with. Then we are going to talk about the network, which is the unsung hero, or you can say the critical aspect, which often gets missed out. Following which we are going to speak about a strong cloud foundations, followed by high performance connectivity and why it's required. Then we are going to give you a brief about the network security and zero trust, followed by a practical hybrid pipeline using cloud providers like GCP, HashiCorp, Terraform, along with a reference architecture and the next steps that the audience attending this session can actually go through. We have seen over the course of time, like every time there has been a new technology that has come up, we have seen a great transition. There has been some initial challenges, there has been some initial bottlenecks, but eventually once we have done that transition, the impact, the usefulness, the challenges that that technology has helped to sort out has been of very great help. For example, when the mobile telecom technology came, it had a great impact where a lot of complicated ways, or you can say the traditional ways of how connectivity used to be done, was simplified. Then came the internet boom, where with a click of a button, people were able to send emails. With the help of social media, people were able to connect across different users across different countries. They could engage themselves in different community forums. And similarly, when the cloud computing came, we see a transition from on-premise hardware infrastructure to the cloud infrastructure, where the companies now were more focused towards the business problem, the business challenges, the problem statements they were working towards, instead of focusing on the background infrastructure like uh, purchasing the hardwares, setting it up, and then managing it up. Now, once the cloud computing came, all of that was abstracted and handed over to the cloud providers, with the interested companies only being focusing on their core problem statement, their core business problem or business statements that they want to simplify. All these transition had their own pros and cons, and eventually as they matured, the things became stable, and we are seeing a great uses for each of them. Similarly, the fourth transition that we are seeing right now is for the artificial intelligence, where we can see how the complicated tasks are being simplified. In fact, you can see you can even observe that one reason for the artificial intelligence doing wonders is probably because of cloud computing, because the heavy infrastructure which previously otherwise used to be handled by the folks or by the users on their on-prem now can easily be provisioned as an on per demand using any of the cloud providers. For example, like GPU, TPU in GCP can easily be provisioned, as in when a user wants, they can quickly get start, bring up an instance, set it up, and then continue to use it. So this is the beauty of how the artificial intelligence has worked incrementally and is helping users to simplify a lot of many things. And we see how useful it is. However, with every new transition or new technology comes a threat. And in this section, we are going to highlight the threats which are specific to the AI. These threats can be categorized into four categories. We call it as model, application, infrastructure, and data. So by model, we refer to the threat which is, you can say, specific to the model manipulation and evasion, like doing the prompt injections where someone can craft malicious inputs to language models. and exploit vulnerabilities. Similarly, model evasion, where an adversarial attacks involving some perturbations of input data or uh, like doing or designing or intentionally doing the model to misbehave, to provide misclassified data or unexpected behavior, or even like insecuring the model output if output filtering or monitoring are inadequate. So AI models can generate misleading or offensive or even at times unsafe data, which is something that none of us would be looking for. And this is where we should make sure that this threat is handled well in advance. The next threat we will be talking about is the application compromise. For example, one common use case of this is denial of ML service, where our service, which is providing us the use case of ML application, is unable to serve or provide the, you can say, unable to provide us the response or the functionality that it was designated to, where manipulation of the resources or overloading the AI system had made the service unavailable or disrupting the operations that rely on AI output. Now, this is where this is a threat on the application pillar, which compromises the functioning of our AI use case. The third one that we are going to talk about will be the infrastructure for AI, where let's say some cases of it could be the model backdooring, where let's say a user while training or let's say uh, um, with a malicious intent, someone while training the model had provided or injected a hidden trigger that allows an attacker to manipulate the model's behavior with specific inputs later on. So once the model has been trained and everything is ready, during the training they injected it with a hidden trigger that it behaves in a certain way when injected with with an input, and that behavior is something the which someone then tries to use when the model is functioning. So things like this is something that we should make sure that infrastructure for AI is also pretty much secure, and the model is handling this pretty nicely, and all the infrastructure which revolves around, whether be it during the training, during the ingestion, or during the inference, are being appropriately safeguarded. The fourth pillar we're going to talk about will be the data exposure, which is another critical aspect because the data is the new IP, as we often say in the AI ML world. So we have to make sure that the sensitive data leakage is always being handled. The effort sensitive data or the data in the model poisoning is being avoided, where anyone who tries to inject malicious data during the training or retraining to degrade the model performance is detected well and early to create any hidden backdoors. So this is something which strictly should be avoided, or at least some safeguarded measures should be put in place to avoid such scenarios. And the last one will be the in the same data exposure, I would say, is like how to have or avoid unnecessary storage of data used to train AI models, which can create legal and ethical risks. These are some of the threats that we should make sure that we are handling well in advance for the uh, to have like a pretty good AI model functioning. While all these are all the threats that you and us are discussing for creating a robust AI ML platform, but network has been like the slide says, unsung hero, which often acted as like a critical bottleneck if not handled properly. So AI ML is something we'll say has been powered by data, and this data is like a large amount of data in huge chunks, and this data is something which travels a lot. It travels from one component to other. It travels in millions of tokens, and uh, for this travel to happen perfectly, if we have a poor network design, then it will eventually lead to critical bottlenecks, like the data will be transferring slowly. We can expect some training failures. We can see certain times outages. We can even see not being able to conclude or provide an inference well in time. So these are some of like very basic things, but are often misjudged. Like while we are planning or thinking about AI, it's not only about AI. It is AI on top of the existing infra, existing network, existing security that we have provided, we have built in. So there's something that we should definitely have well in advance. For example, like if we are planning to build a strong cloud foundation, then things like zero trust architecture, network segmentation, firewall rules, VPC, security groups, IAM permission, encryption, high bandwidth connectivity, all of this should be catered well in advance, or at least should be thought or brainstorm, or should be handled, or is something that should be there in our discussions from the very day one. We spend so much time on models, algorithms, but what about plumbing? So this is the slide that sets the stage, that where what are the strong cloud foundations which one must use to plumb all the necessary components together. So zero trust architecture means we only provide the necessary permissions. We only whitelist the necessary firewall rules which are required. The network segmentation, we logically isolate the network which is being used for AI ML workloads and ensure that it only have the necessary firewall rules, the IAM permissions, which are going to be used for that reason. Same is the case for IAM permission, where we are whitelisting the IAM rules or providing the users with the appropriate access for which only they have or they require read and write permissions. So with that in mind, the next thing that we have is encryption in flight and at rest. So this is again like this can be achieved in form of encryption, or we can even use confidential computing to ensure that the data that we have, whether it's in transit or is it in at rest, is always encrypted. And the last point that we have is a very important point, which talks about high bandwidth connectivity. So what do we mean by high bandwidth connectivity is the data which flows in large chunks have sufficient capacity that the high bandwidths are supported, or the transfer rate for huge requirements can easily be upgraded it to. Like if our network is strong enough, or if we have designed an architecture that can support connectivity across on-prem, different cloud providers, then it's going to ensure that the bandwidth is not going to be a bottleneck for us going forward. Some of the problems for high performance connectivity, as I have to say, is like if we don't have thought about this, if we have not connected this problem statement, then the large data sets that we have is going to take forever to move. So the way to address this is you can use cloud interconnect for high bandwidth connection. If you are trying to communicate from GCP VPC to on-prem or to any other cloud provider, if we are using it for internal communication, you can try out using Private Service Connect, you can use VPC peering, you can use various similar ways or within VPC connectivity to ensure that a very fast data transfer rate is achieved. Similarly, the network security and zero trust that we briefly covered in our previous slides, we intend to say that zero trust means that no service by default is expected to have permission, or basically like no service is trusted by default. So the way it's implemented is we create specific least privilege rule for traffic flow. And similarly, every service gets a unique service account and we only grant only the permission it needs. So it's like a bare minimum permission that it will have, that is required for it to achieve or to have its functionality. So this is how we achieve the zero trust and network security by using the our traditional way of securing our infrastructure. Now we're going to say like how this practical hybrid pipeline can be achieved. So we have a reference architecture, but the way this has been achieved is we provision the entire infrastructure using HashiCorp Terraform. And the reason for this is like there are certain set of guidelines, certain set of best practices, certain set of rules that we just discussed, whether it was securing the infrastructure by zero trust, by restricting the IAM permissions, by setting up the firewall rules, by creating cloud interconnects, or by means of ensuring that the resources that we have, the data that is being transferred, it's always encrypted. So all this is configured by using reusable and repeatable code, infrastructure as code by using Terraform at its core. This helps us to write reusable, repeatable code that helps us to provision the necessary infrastructure for deploying or for creating AI/ML workloads. So this then can actually be used to write your development environment, which you can then further move it to the next stage for your pre-production environment, and then eventually, if everything seems fine, you release it in the production environment. So that's the beauty of HashiTalks Terraform, where you can write reusable, repeatable code, which you have tested to create secure network foundations, and which then eventually you can identify any loopholes, if any. You can fix them in your dev environment, release it into your next stage, which is pre-prod, and then eventually releasing it to the prod. So this is where this repeatable code plays a key action. Now, the architecture that we are going to talk about covers the data ingestion, where you can actually stream the data from on-prem via interconnect and then save it securely in the cloud storage buckets. The last one is we can use a Vertex AI service. Like in this case, in this example, we have used an offering by GCP called Vertex AI Vector Search, but you can use any of the services, any of the service as per your requirement, as per your use case. But the focus here is going to be majorly onto your networking foundations, onto your networking block, so that it can actually support or scale to your different uses and needs. So here is a quick reference architecture of what we want to try to speak about this network foundations. So starting from the left, you can see we have cross-cloud interconnect, cloud interconnect, and cloud VPN, all connected to NCC logical hub, which then sends traffic to your on cloud, which is in this case is Google Cloud Customer Host Project. So this is the core crux of our networking foundation, which we have done to ensure that your project in the Google Cloud, which is the middle box, the customer VPC project, has the ability to connect to your on-prem compute resources, your compute resources in other cloud providers, as well as in any other third-party data centers. So this helps you to not only, like, you can start small, where let's say you only have your data present in the on-prem. So from on-prem to HAVPN, or from on-prem to cloud interconnect, helps you to establish connectivity with the Google Cloud Customer VPC project. However, if you want to further scale it to bigger use case, you can then reach out to any of the cloud providers, use the cross-cloud interconnect, and via the existing setup, you can easily scale your computation, because as the demand grows, as the workloads grow, as the data grows, the requirement for the compute resources, GPU, TPU, will eventually also grow. So having the adaptability to support multiple clouds, multiple data centers, on-prems, appliances is a very critical aspect in this. So in this example, you can see we can say an on-prem connects to the NCC logical hub via cloud interconnect, which then helps to establish the connectivity to the Google customer managed Google Cloud. And for the example, the red arrows denotes the request being routed for the Vertex AI vector search. So think of this diagram as a plug-and-play model. Like on the extreme left, you can choose cross-cloud interconnect, cloud interconnect, HAVPN, either one of it or all three of them based on your requirements and your connectivity, where your workloads, where your data resides. And on the extreme right, we have taken an example of Vertex AI vector search. Now this could be a case where this is not necessarily that you're looking for this service. You may be looking for some other services in Google Cloud, or you may be looking for some other service in any other cloud provider, in which case you just replace this block, this module, with the block or the module of other services sitting in another cloud provider or on-prem. So this is like a plug and play model. You can easily replace any of the services with other service of your offering, but the networking is the main part which remains the same. Now we have got this implementation for you with us as well. So we knew that this is the complicated part. This is the interesting part. So the way you can actually try to do this is, it is like a very, I'll say, mundane task to do it manually. To, like, you can do it once, but every time you have to set it up again and again and again using Consul or any CLI, it is going to become a very, very tricky job to do. So the best way to do this is with the help of Terraform, and this is where the next steps will be there for us. So we have intentionally broken it down into 2 steps. So you can see each of the step is eventually going to land you to a GitHub README page, which is an open source repo. And what it helps you to achieve is it gives you a detailed guide of how this automation using the Terraform works. So the step 1 helps you to set up a secure hybrid network connectivity, and you can either connect at the on-prem or other cloud provider using NCC, which runs in the GCP. So this is where you can say the networking backbone resides. And once this step 1 is set up, then you can actually move on to the step 2, where you can either use Vertex AI vector search over this network that you have already set up in step 1, or you can replace this step 2 with any other services or any other use case that you might already have. So think it of a way where step 1 is a mandatory, while step 2 is something that if you want to implement the same architecture, you can do that, or you can try out any other services. So we have a bunch of services already in the same repo. You can try any of it, be it Cloud SQL, AlloyDB, Vertex AI Workbench, Vertex AI Online Endpoints, and many other services, to name a few. So, or if you have any other requirement for any other services which is expected to work with any other cloud provider, so you can do it yourself. These are some of the combinations that you can try it out. However, if there is something that you need explicit help on, or if you're looking forward how that can be automated, you can probably try to raise that as a GitHub issue or tag me out there, and we can see how we can work together to bridge that gap. But this is pretty much what I had in setting up your secure cloud networking foundations for your AI ML workload. I hope this session was of interest to you, and looking forward.
Thank you, Pradas. That was a great walkthrough and a great deep dive into designing resilient, secure network foundations for AI ML, from zero trust to high performance connectivity, all the way to hybrid pipelines. And I also have to say, I was glad to see some GCP in the house. Y'all know me, I am a AWS woman, but I do love GCP from time to time. So big thanks for that perspective. Now we're going to keep it rolling with our next speaker. Before I get into that, y'all know me, we're doing this live. What can I say? It's hard to read. I accidentally scrolled too far down our programming list and jumped to Paras, who was actually going to go a little bit later in the program, but I'm going to get us back on track. One with the first quick announcement. Remember, we will be sharing all of these talks on YouTube in the coming weeks. So if you are just tuning in, you can catch up later. Now, the next speaker who was supposed to go before Shala goofed up is Neil. So we're going to jump into prevention is greater than detection and writing Terraform unit tests for security. Let's get it.
Hey everyone, hope you are enjoying HashiTalks. So today we will be discussing on prevention better than detection, and we will be discussing Terraform unit tests for security. How you can secure your Terraform scripts, Terraform code before going on a debugging mode. So yeah, hi, this is Neil Shah, a DevOps community guy. I work as a developer advocate at Middleware, and I love to build communities in my local region. I also organize HashiCorp in my local HashiCorp user group in my local region. And I have done more than 50 plus hackathons and have given talks in 10 plus conferences, including the KubeCon, PlatformCon, the Community Day, etc. So when prevention is better than the detection. Most of the breaches, as per the Gartner's report, that 90% of the cloud breaches is caused by misconfigurations. So detection is reactive, but prevention is proactive. So we need to detect and we need to test properly before it goes into production. So cost impact. If you see the amount of cost that fixing in production is more 10x expensive than fixing in development, you can consider how like it can impact a business. So where actually you know Terraform workflow, that is code, plan, apply, and monitor, observe. So actually we can do testing properly. So it will be lesser cost and it will be lesser impactful. So you can do that in the code section. So before plan, you can have unit tests for security. You can also before apply, you can also have policy as code. You can use OPA or Sentinel. After apply, you need to monitor all the things and also threat detection. So this is a big scale. You can do that, but you need to apply the test cases at the code level. The shift left security approach. You might have heard the term shift left. It simply means that we bring security into the earliest stages of the software delivery process. For instance, infrastructure as a code, IAC, that means embedding security into your development workflow. We are not waiting for manual code reviews or cloud security scanner. Instead, our CI/CD pipelines runs automated unit tests for security every time when we commit. Similarly, you can set a proper observability. It will help you understand what went wrong and it will help you to gain more insights into your internal state of a system, and it will be more beneficial for you. Next comes what are the types of Terraform security tests. First is static analysis. We consider linting and rule enforcement. So linting is basically we use tflint, tfsec, checkov, different sort of things. It will see how the patterns, how it matches, and also the syntaxes of the files. Next comes unit test, which will be we majorly focus this time. It will execute Terraform modules in a controlled manner and isolated environments. So there will be a different testing environment where all the things will be tested and it will be destroyed when the test is done. It will specify security requirements, and also we use TerraTest custom. We can also use custom GPT, Golang or Python test cases. So TerraTest is a Go-based hook directly into your. It directly hooks into your Terraform CLI and lets you set conditions on outputs and resource configurations. Next comes integration test. It runs against your deployed test environments, verifies your actual resource provider behavior, how it behave. And examples of this are inspect. You will see as a simple example of that. Post deployment validation script also. Inspect is where if you want to bring a compliance as a code approach. Custom scripts work well when you have highly specific organizational security requirements. So these are the different perspective. Wherever you want to integrate security, you can use any one of them. Next is policy as a code. We will also see an example of policy as a code. It will enforce on the organization level and it will be there after you apply over there. So policy as a code is very much important for big organization to have proper security on every code bases which are going to production. So for this they have OPA, that is Open Policy Agent, and the HashiCorp also they have a tool HashiCorp Sentinel, so you can also use that. So why unit test? For example, so go beyond linters. Just after validating, go to each and every aspect where the security can be breached and consider different things like it can also detect misconfigurations. It can also specify organizational rule policies. For example, you can write a test to assert that an IAM rule has only approved policies. That will be one thing because we don't know how many IAM approved in our current provider, and we want that only these people can only touch the code. So we can apply that. And we can also test that before going on that production. Apart from that, we as a human we generally ignore a lot of encryption. So every S3 bucket has encryption enabled so that no security no security fraud can be happen there. So you can also implement this sort of test cases via Terra test on S3 buckets, and you can also see if they are enabled or not. Also, you can also see the open ports. If 22 is not open to everyone, so everyone can inject anything and get your data over there. It will be also much very beneficial for you. Apart from that, we have network boundaries. So there are VPCs, and security groups. You also need to check that, like from which portion inbound and outbound data flow is approved or not. See, here is a Terra test. It is for IAM role, which I was discussing previously in the previous slide, like how you can validate IAM role validation with Terra test. So Terra test, there we have Terraform destroy. So the role name prod read only. So only one only. So no one accidentally creates a privileged role in a production context. The role is only attached in this case to security audit. If someone tries to attach administrator access policy there, it will fail. The beauty of this approach is that we are testing the real Terraform output and not just that we think it will create. So we are actually trying out testing it properly with TerraTest. It is very easy to integrate in your Terraform CLI because it is a Go-based application sort of thing, which you can easily go on Terraform terratest.ground.io and you can easily download the. So how does the actually cycle works? Terraform testing deployment cycle. So the developer pushes code, the CI/CD pipeline is triggered, and the Terra test suits. It triggers the Terra test, and there are setup that it set up the Terraform environment and testing environment there. It will initialize, apply, and do the testing over there in a segregated environment, and it will clean the infrastructure once the testing is done, and it will generate a report. Once the report is generated, it will pass on the alerts and notification if the test was success or nothing, and if it is success, then it goes to production. You can see the whole diagram, the whole workflow, how it goes. There is Terra test use cases, the goal-based thing. Then it comes ISC approves, then only it goes to if Terra tests are successful, then only it goes to prod. Otherwise, it won't. Consider an example inspect like I told about inspect for encryption validation. So here is a sample code base for S3 bucket whether it is encrypted or not. So one of the most common and dangerous misconfiguration in cloud environment is unintended public exposure. It's not just S3 buckets, it's open security groups, public subnets, load balancer without TLS. Because it should always have a TLS attached with that so that after some time if you forget the passwords or something to place there, it directly gets vanished. Network boundary testing ensures that your Terraform code creates only the network exposure you intended. We can write test cases to check that no security groups has 0.0.0/0 on sensitive ports, like all the things are open there. The subnet default to private unless explicit mark otherwise. The load balancer and are internet facing only when justified. That great part is this test can fail before any real infrastructure is preventing a public exposure from even reaching a staging environment. So this will test properly and it will be beneficial for us. This is a like structure of OPA, Open Policy Agent. You can see if someone has requested, then it will check out the whole policies, how it stores somewhere in OPA agent here. And similarly, if you go for HashiCorp Sentinel, similarly it also has a similar pattern. So you can consider if a policy input. See, the request is coming from a role who like person who has a role admin, and if the policy output also matches that admin allowed is true for this request, then it will fetch out. Otherwise, it won't be given out. Apart from that, scaling reusable test cases. Why this is important? Because we can create a lot of test cases for different use cases. So we can try to out for major general things and like IAM roles, encryption. We can use them recurrently. It will give consistency and it will also speed up the test casing sort of thing. It will also maintain a proper environments, proper version of that also, of test cases also. You can store them in some S3 buckets or somewhere to at least you also have backup of them. Auto centralize. Encryption checks. Encryption checks are always needed. IAM best practices, network restrictions, tag compliances. These are the major general things which are necessary for any organization to secure the air. So what are the best practices? Store test libraries in a shared Git repo or a cloud-based storage like buckets. Version your test packages and lock projects to known good versions because sometimes that also if that is incremented and then it will your test cases won't be fair thing there. You can also automate publishing to make updates easy to adopt. The tools mentioned here, the tool on uh, the major of the tools are Terraform, Inspec, TFSec, Checkov, LocalStack, OPA, HashiCorp Sentinel. So major of the tools you can use this for security purposes for your Terraform scripts. You can scan this code if you want to have a whole roadmap of Terraform. I've created this, it is on GitHub repo. And in case if you need some quick help with this, you can also connect with me on LinkedIn. Thank you. Hope you enjoy this.
Thank you, Neil, so much for that. What I took away from that is prevention over detection because let's be honest, fixing security misconfigs and prod is as about as fun as trying to fix a roof in the middle of a storm. Like, it's not good. It would be a terrible time. So, thank you for walking us through how Terraform unit tests can stop those issues before they start. And now on to our next speaker, now that I got us back on track after taking us off track. Actually, before we do that, quick little announcement about joining a hug so that you can connect with other practitioners and community members locally. There it is on there on the screen where you can go to visit. This is super, super important. I love a good hug. Because as you're starting out and things like that and you have questions and you're trying to figure out stuff, a hug is a great place to meet people and connect and learn and all those kind of things. I strongly, strongly, strongly encourage it, especially if you're looking for work. Oftentimes, a lot of times, it's about who you know, and a hug could be good for that. So go join one today. Now, our next speaker is Shruti, and they are going to talk about secure scalable data pipelines with Terraform. Hey, we got GCP again. All right, let's go.
To HashiTalks 2025, I'm presenting a real-world industrial use case where we can build a secure scalable data pipeline with Terraform and GCP. I'm Shruti Era Harera. I'm a data engineer at TELUS International, and this talk is about a project where we had to design a pipeline that was secure from ground up, scaled to millions of daily events integrated with legacy systems, and still pass the compliance audits. What makes this different from my conference example is that it's not theoretical. This is from a real industrial environment. If a pipeline fails here, it's not just the dashboards that go blank, it can impact manufacturing timelines, shipment schedules, or even field operations. So over the next 15 minutes, I'll walk you through the architecture, the Terraform design, the security integrations, and the lessons we learned, including a code walkthrough so you can see exactly how we put the security into the practice. Let's start by understanding the context and why this pipeline was particularly challenging. So a quick intro about me, so you know where I'm coming from. I have over 6 years of experience in large-scale cloud data platforms like Google Cloud and Azure, and my work has been ranged from streaming data ingestion to machine learning pipelines, but my favorite projects are in industrial IoT because they combine like a huge data volumes, real-time processing, and strict compliance requirements. The project you're about to see reflects a lot of these principles like modular design, automation, and security as first-class citizen. So today this is how we are going to have our session. So that I'll be handling the challenges of the industrial telemetry at scale, and followed by the architecture and a Terraform module walkthrough, and then how we built in the security observability and optimization and the results and lessons we learned from that, and then we'll be taking questions. So let's begin with the problem we had to solve. So we had to design a telemetry platform for an industrial client that met our 4 major challenges. So those were like the volume, security, reliability, and integration. So when it comes to volumes, we were receiving millions of daily events from sensors on equipments, peaks about like 5,000 events per second, and these events weren't even uniform. We'd get like tiny status updates and huge diagnostic payloads, often like in different formats. So that was our volume issue. And with security, it was like a sensitive operational data, and if it leaked or tampered with, it could cause not only financial loss but also like operational disruptions. So we had regulations like SOX, GDPR, and enforce encryptions at the rest and in transit, and implement fine-grained access control. And we had to have the reliability, as this was like mission critical, and we had SLAs of up to 99.9% uptime with no data loss tolerated, and downtime could cost like hundreds of thousands of dollars per hour lost in production. And to do the integration, the data sources included like industrial protocols like Modbus and OPC cloud systems, and these had to be securely bridged with cloud systems while keeping IT and OT networks segregated. All of these requirements meant we couldn't just spin up a couple of managed services and call it a day. We needed a cloud native architecture defined entirely as cloud with built-in security and auditability. The entire system is provisioned and connected via Terraform. That means we can create any environment, dev, test, or prod from scratch within minutes with consistent security configuration. So here's a high-level architecture we implemented. We had hedge collection. So the IoT devices with local buffering, so the data isn't lost if the network goes down. Data is encrypted before leaving the device and then passed on to the ingestion layer, where the cloud IoT core and PubSub for durable messages queuing. So this lets us absorb spikes without losing messages and decouple producers from consumers. And then we had the processing layer where we use the data flow with Apache Beam for real-time ETL. Data flow scales automatically and can handle different payload sizes efficiently. And this was followed by the storage layer. The BigQuery for analytics was used and cloud storage for raw archives. The archives are essential for compliance and for reprocessing data if downstream model or query needs historical data. And this is an example of our Terraform implementation. So we had our repo organized like environments and modules and scripts. Environments had like dev, test, prod, each with its own state and variables. And modules had reusable building blocks for PubSub, data flow, BigQuery, IAM, and monitoring. And scripts are like helper automation for CI/CD integration. This structure allows isolated testing and promotes like reusability across the projects. So this is an example of a PubSub code. It provisions a topic for telemetry ingestion, a subscription for processing, IAM binding with least privileges, and 24-hour message retention. This parameterized so we can use the same module in multiple projects without rewriting. And the key here is that security is baked into the module. If you use this module, you cannot accidentally create a topic without the right IAM. It's like the part of the definition. And coming to its security implementation, we approached it in 3 layers. So the first layer is IAM management via Terraform, and then we had a secret management and then network security. And so the IAM management, we had custom roles per services, environment-based conditional bindings, and separate accounts for read and write operations. For secret, we had integration with Vault for dynamic secrets, no static keys in Terraform state, no secrets in Git. Keys are rotated automatically. For network, we had VPC service controls to prevent data exfiltration. All of these settings live in Terraform, so they are version controlled and peer reviewed like other changes. And coming to the observability and monitoring, one of the key principles we followed in this project was if you can define it in Terraform, you can also monitor it in Terraform. So observability isn't something we added at the end, it is built alongside the infrastructure. We use Terraform Datadog provider to create the entire monitoring stack programmatically. Let me break this down. So first we collect the custom metrics from the GCP servers through the API. Second, we build the detailed data flow job telemetry dashboards. And third, we create the automated alert thresholds by the environment. So here is an example of how we created the Datadog monitor. And the benefit of doing all this in Terraform is that it's repeatable. We can spin up a new region or environment, the same dashboard, monitors, and thresholds are created instantly. No manual clicking around like in Datadog. And finally, because of these monitors are in code, so they go through like the peer review. So the deployment delivered like up to 99.98% uptime and sustained like peaks of over 5,000 events per second, and it was like 40% faster processing times than the previous solutions, and 15-minute deployments from commit to production, and we had like 0 critical findings in an external security audit. So the key takeaways from this build is that we need to invest in modular Terraform from day one so that dev, test, and prod stay identical and repeatable, and implement IAM dynamic secrets, encryption, and VPC controls so the security is there by design. And when it comes to observability first, Datadog monitors and dashboards and Terraforms with SLOs and cost guardrails versioned alongside the infra. And team enablement, we have document modules and create usable patterns to scale the knowledge and enforce CI/CD so new services inherit good patterns automatically. So if you copy one thing from this talk, start with a modular transform and add a vault early and ship monitors the same days you ship the infrastructure. And I have a small demo on the Terraform module structure here. And let's walk through the secure pub/sub pipeline with the Vault integration. And so we have like the source, the version, the topic, and we have the subscriptions that we are required. And this creates the topic subscription and applies least privilege IAM and sets a retention policy. So this is followed by the Vault integration. So in Terraform, we configure Vault GCP secrets in backend. So this tells the Vault it can issue short-lived keys for our pipelines SA with only publisher rights. So the Vault issues short-lived auto-rotated credentials for our pipelines, no static keys in Terraform state or repos. Every secret access is logged for compliance, and permissions are restricted to exactly what is needed. For example, just the pub/sub.publisher and BigQuery.dataEditor. This greatly reduces the risks and simplifies the audits. And during the runtime, we have like the Terraform provisions infra and Vault config. We have pipeline job starts. We have Vault issues to key validate for an hour. And we have like job publishing messages and key expires automatically. So this way, no long-lived keys exist anymore, and we can pass audits without scrambling for key rotation logs. So the future directions and innovations lead us to AI/ML prediction scaling to anticipate load before it happens, and zero trust architecture for continuous verification of every request, multi-load Terraform modules for probability across providers, GitOps workflows to validate and deploy infra changes automatically. And then the performance optimization techniques, we tuned data flow auto-scaling, used custom machine types, and enabled the streaming engine for throughput. In BigQuery, we applied partitioning, clustering, and materialized view to reduce costs and query times. And when it comes to network design, we use the VPC service controls and private Google access and regional deployment to improve security and lower cross. So the real world implementation challenges that we faced are like the state locking issues fixed with CI/CD management deployments, credential rotation gaps, like over permissive IAM roles, and uneven scaling too. So like this credential rotation gaps this was solved with overlapping validity. Over permissive IAM roles was replaced with custom least privilege roles, and uneven scaling resolved with backlog based auto scaling and dead letter queues. So if you have any questions, you can always contact me with this details. And Thank you for your time, and I hope these patterns from modular Terraform to Vault-based secrets help you design pipelines that are secure, scalable, and cost-efficient from day one. Thank you.
Thank you so much for that, Shruti. And shout out to you in the chat. If you all have questions about her presentation, be sure to pop them in the chat because I saw her in there. So just saying. And also that presentation speaks very near and dear to me because I am all about modular Terraform, building security from the start. And y'all know me, observability, like I'm forever in CloudWatch logs and stuff like that, try to make them better. But if you've been watching me, you all know I love creating Terraform modules once and then being able to reuse them again for various projects so you're not starting over from scratch. And the way Shruti was able to show, like, the data, the results from doing that, amazing. Now, another reminder announcement. Do not forget that Hashi Conference is coming. That's going to be September 24th through the 26th in San Francisco, California. Let's see, I think a link might get popped up on the screen so that we can find out more info about it, but be sure to check that out. I will be there. Probably a number of the folks you're hearing from yesterday and today will also be there, so definitely check that out. Now, is that right? We're on our final speaker. Is that correct? All right, so let's keep this going. And our final speaker is going to be Raul. And we're talking secrets without secrets. All right, let's get into that.
Good afternoon and good evening, everyone. Before I begin, I want to take a moment to thank HashiCorp for giving me the opportunity to speak at HashiTalk. Securely Building. It's such an honor to be here with this amazing community of builders, security professionals, and innovators. Today, I'm going to share something I'm deeply passionate about. How we can move towards what I'd like to call secrets without secrets, using federated identity across AWS and Azure. Before we begin, let me introduce myself. My name is Rahul Raj. I have 10 plus years of expertise in IT industries. I have played multiple hats, so as a solution architect, consultant, and now I'm playing positioned at DevOps manager at Autodesk. Let's start with a scenario I'm sure many of us have lived through. You open a code repository, maybe one of you haven't touched in months, and there it is, untucked away in a configuration file, an AWS access key or an Azure client secret. Sometimes it expired, sometimes it is still valid. Either way, it is a security risk, just waiting to be exploited. This problem exists because in traditional cloud setups, we rely heavily on static credentials, static secrets, API keys, passwords, database connection strings embedded in code and configs. They are long-lived. They get leaked in logs. They are hard to rotate without causing downtimes, outages. And once someone has them, they have got the keys to the kingdom for a long time. But imagine a different world. One where your application stores no secret at all. Instead, whenever it needs an access to AWS or Azure resources, it proves its identity and gets just-in-time, short-lived credentials. Credentials that automatically expires quickly, sometimes in minutes. That is secrets without secrets. And the technology that makes this possible is federated identity. And right in the heart of that solution, we have HashiCorp Vault acting as a central identity broker. Here is a big picture. Workloads authenticate to Vault using their identity from a trusted source. Vault exchanges that for short-lived credentials from AWS or Azure and no static secrets are ever stored in your code or environment variable. How secrets without secrets actually works, right? Let's quickly unpack the core ideas behind before I show you the magic in action. Dynamic credential issuance. Vault can generate ephemeral credentials on demand. AWS and Azure trust Vault to mint these credentials, and they come with a short TTL. Or so even if someone gets hold of them, the window to misuse them is tiny. Federated identity with OIDC. The glue that makes multi-cloud federation possible is OIDC, OpenID Connect. It's an identity standard that lets Vault prove a workload's identity to AWS and Azure without secrets. Instead of a static key, we use an identity token exchanged securely for cloud credentials. Multi-cloud and zero trust. This works across providers, meaning you can have a common identity strategy for AWS Lambda, Azure Functions, Kubernetes pods, all with a consistent authentication flow. It follows the zero trust principle. Never trust, always verify. Every credential is short-lived and workload specific. Quick question. Who here has never stumbled upon a secret in a code base? Maybe I am. Exactly, right? This is why we need to rethink secrets management. What you will see in the demo. All right, so now that you see the why and the key concepts, let me give you the roadmap of what we are about to do, right? In this demo, we'll set up Vault to federate identities with both Azure and AWS. First, in Azure, workloads will authenticate to Vault using Azure AD issued tokens. Vault will then dynamically create Azure credentials from them. Then in AWS, we'll switch to AWS, where Vault will act as an OIDC provider itself. AWS will trust Vault's identity tokens to create short-lived IAM role credentials. Again, no long-term keys anywhere. We will watch credentials being requested on demand, used, then expiring. No secrets stored, no rotation headaches. Let's roll up our sleeves and jump into the demo. I'm going to follow a GitHub README file, which will be shared across with you post the session is over. And in this README file, I have documented every steps and every commands which someone can follow along and configure these with Azure and AWS. Couple of prerequisite items which you need to follow. I'm using HCP HashiCorp Cloud Vault cluster for Azure configuration and a demo, and I'll be leveraging ngrok. I'll be initiating a Vault dev local server for the AWS demo. Do note that you might need an enterprise license in order to use workload identity federation. You might need Azure subscription, an AWS account, and obviously, so an ngrok. So ngrok is an application or a tool which points your local host to publicly resolvable DNS endpoint. You might need other packages like jQuery, OpenSSL to configure SSL, Azure CLI, and AWS CLI. Because I'll be doing everything programmatically and a couple of things on the console to show you how things on setups looks like. So this is my Vault cluster, which is up and running, and this is my public endpoint. This is my private endpoint. So let's try and configure it for Azure first. So I have my own subscription. I have created 2 app registration, and I'll not deep dive into app registration detail. So in the app, I have 2 app registration. One is Vault Azure, where we will try and configure Vault with client ID and client secret first and see how things are work. And then we will get rid of that and set up our workload identity federation within Azure app without client secrets. So I'll open my terminal, and I have set things up before. So I'll just walk you through with the environment. Couple of environment variable. What you might be needing is your Vault address, the cluster address, which you can grab it from HashiCorp Vault console portal. You might need to generate a Vault token, which I'll be doing in a minute. So here is the Vault generate token, and you can generate a new token from here. So I just generated 1 token for me to use. and copied it, and I'll be just replacing my token in the configuration file. Okay, once you have this token generated, you need to also export your Vault namespace. So anything which is running inside HashiCorp Vault Cloud, by default it gets created in admin namespace, and we do not have much control on the admin namespace. Next, what we will going to do for this demo, we will create a different namespace, HashiTalk, and then we'll use that namespace to create our configuration and everything together, right? This is how an Azure integration, like for this static credentials, if you want to configure static credentials for Azure Secret Engine, you need to enable Secret Engine first. Then you have to set up your Azure configuration. This is one way of doing it. This is using the static credentials, right? Where you'll be leveraging subscription ID, tenant ID, client ID, and client secret. In this case, what I'll be doing, I'll be leveraging Vault Azure, as you can see on my portal. Let that come up. I will create a client's secret, and I'll be leveraging that client secret to configure the Vault Azure configuration, and then we will try and generate the credential first. So this is, and then I'll be just creating a role with the object ID and try to read this. So this is how traditionally somebody selects and configure their Azure configuration or integrate Azure Secret Engine, right? So let's roll up to the terminal quickly. And here on my terminal, I have already two-speed created some script, which I'll quickly show you as well, so that I do not write these codes. I'll be sharing these codes on the GitHub repository. So first, let's go with Azure Secret Engine. Here, I'm just what I explained. I'll be replacing this token because this token is will be expired in by the time you will watch this video. So no worry, don't worry about it. And what I copied the subscription ID, tenant ID, client ID, and client secret from the particular Azure app, which I just shown. So most of the details you will get in the overview section of that particular app, and the client ID and client secret, what you will be getting. So you will get all these details. Once you have this detail, it's pretty much simple. You enable Azure Secret Engine, you give your client ID and client secret, and boom, you should be done. So let's try and execute this. And if everything goes right, it's going to configure Azure Secret Engine for us with client ID and client secret embedded into it. So as you can see, it created a new workspace, admin HashiTalk, and then you can see that the ID of that particular admin namespace is this. It then enabled Azure Secret Engine at Azure. It then tried configuring Azure configuration, which I'll show you using this particular command, and then it created a role, and then it tried to create a role. So basically what happened here, if you see on the portal now, and if I go to client and secret, you can see that this particular client ID and secret are what I used to configure this engine. And when we tried reading this particular credential, which was created using the client ID and client secret, it created another client ID and client secret for you, right? So, and let me command which we ran, which generated credentials for us with client ID and client secret. We have another plugin, Secrets, which was created for that use case. Inside Vault, you will see that one Azure mount path, which is created just for this use case. Now let's move on to how can we switch to workload identity federation, right? Here we were using a client ID and a client secret for our configuration. Now for that, let's look into our OpenID Vault configuration, which we need to set up the workload identity federation into our Vault portal Azure app. So you will get this endpoint from the public endpoint, and in this public endpoint, you need to append identity OIDC plugins, well-known OpenID configuration. When you hit this particular endpoint, let me take the cluster endpoint. This is going to be the cluster endpoint, and then Vault URL I should be replacing. When you will hit this endpoint, you are going to get an output of OpenID configuration. And what we are most interested in this, one thing which you need to consider, that the endpoint which your Vault is set up with should be a publicly resolvable TNS in order to workload identity federation to work. We are interested in the issuer URL, and this is what we are going to set up and use for our workload identity federation configuration. Now for this, what I'll do, I will be using a different app which I just told. So let's go to Intra, Microsoft Intra, app registration. By the time it's loading up, I need to clean up my Azure configurations as well, so that we can work through for the next one. So what I'll be doing, I'll just disable the Azure Vault, Azure mount path what we created, and we'll re-enable it and then configure the Vault again. So let me just quickly do this. All right, I think I'll have to log in here. So anyway, let's log in. That's not a challenge. Let's log in into, let's set this address, or let's do this. Let's delete it from here. Let's delete it from the terminal, right? So what I can do, I can just go to Secret Engine and let's disable it. And there you go. All right, and what we will do, we will just enable the Secret Engine once again for Azure and enable. So this is getting enabled at admin task, and what we need is the ID of this particular Secret Engine. Hopefully this is came up. So in the all application list, now we will be using Azure Workload Identity Federation app to configure it. Now here, if you see, you will not find any secrets configured with this particular app. And just for for the simplicity and to understand that we are not mixing both, I used a different app. So you can see there is no client secret and client ID here. Instead, what we are doing, we are leveraging this federated credentials. You can add credential. I have already created one credential here. So you can just, I will show you the configuration of it. You can select in the federated credential scenario, you have the multiple option. You have to go to other issuer. This is the issuer I was talking about. So this is what the endpoint Vault Azure would be sending requests to, and this URL is built of your cluster endpoint followed by your v1, and then this is your namespace. So namespace is mandatory. If you forget to namespace, you might not be able to connect. And then identity OIDC plugin. Type, you can keep explicit subject identifier. Value, in the value format is plugin identity is hard coded. Then this is the ID of your namespace, where if I show you in my terminal, the moment you will create the namespace, you will get your ID. So I'm going to replace this with my newly created ID. And here I need the Azure accessor ID. So I'll just go ahead and grab the accessor ID of my Azure Secret Engine, which is this, and do the configuration here. that's it. This is it. And the name can be anything. You can write it. Audience, you can leave it as it is, and you can just create. And for me, I'm just updating it. This is done. So this is the configuration what you need to do on the Azure app for this to work. From the Vault, let's go back and switch to our README file. Now, in order to work with workload identity, here if you see that, again I'm going to export client ID, tenant ID, subscription ID, but here I'm not importing or exporting the Azure client secret, which is not needed in this case. And then I'm going to do the similar configuration again here. No tenant ID, no secret ID, which I'm mentioning, but instead this is a mandatory audience which you need to mention, which is going to be Azure AD token exchange. This is going to be similar looking what you had set up in your Azure workload identity federation. And that is it. Once this is done, you should be able to access it. Let's run it, and then we'll see how it goes. Well, I'm on my terminal again, and I'm going to run another script, which is workload identity federation, and then let's see. Okay, Azure configuration data is written, Azure roles is created, and boom, there you go. You got a client ID and a client secret, and this time we did not use Vault client secret. And if I go to my Vault, and if I just reload this Vault configuration, you should be able to see the configuration of your Azure secret engine. Right, it's loading. Here you go. You can see that identity token issuance, this cluster issuance, issuer is this, subscription ID, tenant, and client ID. That's it. You are not worried of secret, and now you can exchange a token with Azure to get you client ID and client secret, which is short-lived, and you can revoke it when it's not needed. That's for Azure. Let's switch our gear and move towards AWS. How is it possible for AWS, right? So for the AWS workload, I'm not going to use the HashiCorp Cloud Vault. Instead, I'm going to set up a local dev server and using NGRock, I'm going to expose my local endpoint to publicly resolvable endpoint. And let's see how we can do it. Once that is done, there are certain configuration items which we need to do. For example, you need to set up Vault API address, which will be pointing to your NGRock forward, on the address. Let's see, and then you will be able to understand. So I have opened 3 terminals here, which you can see. In the first terminal, I'm going to use NGRock and redirect all my traffic, localhost traffic for 8200 to a publicly resolvable endpoint. So now this is going to be my new publicly resolvable endpoint, which will resolve to my 8200. Using this endpoint, I'll be initiating Vault dev server. And how can I do that? Let's see. So let me set this up. I have written a lot of commands, sorry for that. So this is the API address which I'm going to replace here. The new API address is going to look something like this. And here in this particular path, I have a Vault Enterprise license. So you might need a Vault Enterprise license for in order to configure this with workload identity federation. And I am also setting up access key and secret access key initially just to interact with AWS, and then we will initiate the server Vault, right? So let's see how does it look like. So what I'm going to export all these into my second terminal. I let this keep running. Let me clear the screen, and here you go. And next, let's initiate the Vault dev server with where I'm saying that initiate the Vault local dev server with root token as root, and this should bring up the Vault dev server, and I should be able to reach my dev server using the endpoint which is given by ngrok. For example, if I have to show you, I can resolve this endpoint now on a public URL. So you can see that it might give a warning first that you are accessing site which is free. That's true, and you can see that now I'm able to see the Vault Enterprise here. I can see the UI now. Though I'm not going to log in, I'll just close this terminal up. Once we have this ngrok running and Vault dev server setup, what I can do, I can try and export the Vault address and see if the Vault is really resolving. Let me copy this new endpoint and paste it here so that I can use it. So what I'll do now, I'll use a third terminal for this. I'll export the Vault address and the Vault token, and I should be able to get the status of my local Vault cluster, right? And you should be able to see that what's happened. First path segment cannot colon. Okay, I think there is some double equal to. Let me remove that and then paste it again, and I should be able to see the status of my Vault cluster, hopefully. Yes, here you can see. So I'm not running a binary open source binary. Instead, I have an enterprise binary with the license, which is going to expire in some days. So you need to have that enterprise license in order to export, use this workload identity federation. So now, what I have done so far, I used ngrok. I redirected my localhost port 82002 to a publicly resolvable endpoint. Then I initiated my Vault dev server on a local host, and this is how my cluster looks like. Let's move back. Once you're done with this, you may need to prepare OIDC thumbprint and metadata to configure your OIDC endpoint or OIDC configuration for AWS. So what I'm doing basically here, I'm just generating a domain. I'm fetching the domain from this well-known OpenID configuration, which I just was talking about while doing the Azure configuration. Once you have the domain, I'm using OpenSSL certificate, OpenSSL command to generate a certificate, and then generating a thumbnail, a thumbprint for that particular certificate to configure it. And I will quickly show you where and why we need this, right? Once we have this, we are also going to create a role and a trust policy, which will be used to assume that particular web identity federation and help you generate the credentials or create IAM user or whatnot. And these are certain permissions which you might be needing at minimum to get away and get started with this. So I have documented everything. All the commands are going to working, and I'll show you how does my AWS accounts looks like. Now this is the place where you do your identity configuration for AWS. So you go to AWS console, you go to IAM, and then on the left panel you select identity providers. So now you can see that I do not have any identity providers at moment. For validation sake, I will also show you there is only one user right now. There is only one user right now in the IAM, which is my user, which I'm using for this particular demo. And if you see, there is only 4 to 5 roles which is created because we'll be creating a role, so you should see and understand. So there are 4 roles what you can see in my console. Let's see. So let's go back to our IDE. So this is all AWS command. So what I'll be doing, I'll be just doing the configuration for AWS first, where we'll be creating OpenID connector, set up a role and everything, and then we will move on to setting up Vault. Let's go back to our terminal. Let's clean this up and execute the command. So I have noted down the command as well. So this is very simple. I'm setting up AWS I'm passing my the new endpoint of Vault. I'll have to copy and replace this, otherwise it's going to throw an error. Let me do this as well. Okay, and let me just run this. What it will do, it will connect to my AWS account. It will create role. It will set up identity broker, and it's going to create yeah, I mean that is that, create policy and then attach it with that particular account, right? And so while this is working, let me go and show you on the AWS console what's happening. Right, in the AWS console, if you see now, I just refreshed roles. I think the roles are still being created, and soon we should be having a role. Yeah, so you can see that there is a role which is now created, Vault AWS Secret Engine, and we should also have an identity providers created for that particular Vault endpoint. So still working on it. Let's reload this page. Okay. Come on. All right, here you go. So we have an identity provider created and set up for AWS. You can see that now this is the identity provider. There was nothing, and now if you can see, you can click this identity provider, and you're all set. So you have an audience. Audience can be anything, any text. You need to make sure that this is same configured as part of your trust. Endpoint verification, as I told you, the thumbprint which is created in order to validate. So you can add up to 5 thumbprints. This is your provider. So we are all set from AWS side. And you can see in the user section, we still have only one user, that is my user, right? Now, second step, let's try and configure Vault side of it, right? So configure Vault. What we're gonna do? I've just written a program code for this as well, just to speed up the execution. We are going to export the root token address. We are going to configure identity OIDC configuration and set the issuer URL. We are going to enable secret engine. We are going to configure, and you can see that we are not using any access key and secret access key to configure the root credential. Instead, we are using the token audience and role ARN, the one which is created above. And then we are going to create a role, and based on that role, we should be able to grant read permission for that. Let's see. All right, so for that, what I have done, I've created a script where I'm just passing the Vault endpoint and the role ARN which was created. So let me clear up this and then just run it. So this will enable AWS Secret Engine for us. It will set up the issuer URL for identity plugin. It will configure AWS root, and then it will create a role, and it will try to read that particular role using IAM-Crit. So here you go. Everything works fine. Now you can see in the terminal, if I refresh it, here I'm not using assume role, I'm using an AWS IAM credential, IAM user type of credential. So you can see that there is a Vault token which was created without giving any sort of configuration. So you can see that if I just do Vault read AWS config root, I should be able to see. So the role is configured, identity token audience is configured, rest of thing are not here, right? There is no access. That's pretty much it. So if you have any questions, feel free to reach out to me on my GitHub page or on my LinkedIn, and I'll be happy to connect and help you out. Thank you so much, and thank you for listening me. Have a good day.
All right, so what's up, everyone? How is everyone out there feeling? Real quick, if you are enjoying the content and want more content like this, please be sure to click that little like button that you see right now, and also subscribe to the HashiCorp channel if you have not done that yet. And what else? Oh, the other thing I also wanted to say that I think is funny. I finally just started learning Azure like 2 weeks ago. And so now I kind of know it. And yes, I'm terraforming it. Like you already know, I start Terraform first. Like I barely go into consoles these days. And my favorite thing about Terraform is the destroy command so that you could quickly tear everything down. Actually, like absolutely love this talk. I thought it was great. I thought it was solid about having OIDC federated time box access and no static secrets that you're leaking and things like that. So I thought that was great. And what's funny is the way that just this week I've been fighting with AWS and OIDC in my GitHub action pipeline. So this was like right on time. Okay, but that was our last speaker. So thank you so much, Raul. And if you notice, he is in the chat. So if you have any questions, definitely pop them in the chat. Shout out to all the speakers. Before I forget, shout out to HashiCorp and Jasmine for inviting me to come on and help co-host and MC this. I've had a great time. Shout out to my employer, WWT, Worldwide Technology, for letting me take time off from work to do this. So big shout out to them as well. Okay, final announcement. Don't forget HashiConf. Yes, I was happy to be here. HashiConf is happening in September in San Francisco. You see the banner on the screen to find out more information. Join us there. It'll be great. And also, let's pop up some information for joining a hug, HUG. Who doesn't like a hug? Who doesn't like a hug? As I mentioned before, whether you're like beginner, seasoned, super experienced, whatever, it's always good to join a hug community. So that way you can talk with other like-minded builders like you and me. It's great. That's who I reach out to at times when, or a lot of times, let me say, when I'm hitting a brick wall with trying to build something that's just not working right. The people that I meet at conferences and hugs and stuff like that, that's who I reach out to, and I'm able to figure it out. All right. I think that is it for the wrap up. Thank y'all so much for being here, spending your precious time with us. And we'll see you at the next one. I'm Shala. You can find me across social media as @GiftedLane. I'm about to get ready to start back doing my Twitch live streams again, where I'll be working with Terraform, AWS, and Azure, breaking all the things so you don't have to. And shout out to my community for ghosting y'all for 6 months. But yeah, I'm back.